Hi all, welcome to goclasses. In this lecture, we will continue our discussion of SDD, syntax directed definition. So in the previous lecture, we were discussing syntax directed definition, and this is part 2 of SDD. Okay, and this SDT, this we have already studied in the previous lectures. Okay, this syntax directed translation or syntax directed translation scheme, this concept we have already covered in the previous lectures. Okay, so let's continue our discussion of SDD. You can see these are the topics that we need to study in SDD, syntax directed definition. Already in the previous lecture, in the part 1, we have seen the concept of attributes of grammar symbols. We associate attributes with the grammar symbols, means we associate attributes with terminals and non-terminals. Okay, so this concept we have seen. I told you that the attributes that you choose, that will depend on what type of semantic analysis you want to perform. The chosen attributes, which attributes we should choose, okay, that will depend on what type of semantic information you want to compute. Okay, then we have seen the concept SDD definition, syntax directed definition. So this definition we have seen, and I told you what is SDD. SDD is basically context free grammar plus attributes associated with the grammar symbols plus semantic rules associated with productions, and these semantic rules, they will compute the values of attributes. Okay, so SDD is basically context free grammar plus attributes plus semantic rules. Okay, attributes are associated with the grammar symbols, means these attributes, these are associated with terminals, non terminals, and the semantic rules are associated with productions, grammar productions. Okay, and I told you that in SDD we have, we write the production separately, the grammar we write separately, and with the productions, with each production, a set of semantic rules are associated. So we write the grammar separately, the productions we write separately, and the associated semantic rules we write separately. Okay, this is how we write SDD. Okay, very simple. Then we have seen the difference between SDD and SDT, syntax directed definition versus syntax directed translation scheme. This difference we have seen. I told you that SDD will tell you what to do. SDT will tell you what to do, when to do, how to do. Okay, so you can see SDD, this is declarative, and SDT, this is a procedural. Okay, SDD is good for high level specification, and SDT, this is good for execution, for implementation, for evaluation. Okay, very simple. So this also we have seen. Then we have seen the concept of attribute grammar. Attribute grammar is basically, this is, this attribute grammar is SDD without side effects. Okay, what are side effects? Side effects are basically anything other than attribute computation. Okay, other than attribute computation, if our semantic rule, if our semantic action is doing anything, okay, then that is basically side effect. For example, printing on the screen, okay, printing the output, so that is not computing the attribute, right? Okay, so other than attribute computation, if our semantic rules do any extra thing, or any, I can say, outside thing, okay, other than attribute computation, if our semantic rule does something, then we can say it is a side effect. And what is attribute grammar? Attribute grammar is basically SDD without any side effect. Okay, so this attribute grammar definition we have seen. Then you can see we have seen the concept of synthesized and inherited attributes. This concept we have seen, and also many practice questions we have done with a gate pyq. Okay, so in the previous lecture, I can say that these things we have done. Okay, we have already done, we have already seen the concept of synthesized attributes, inherited attributes, the definition, a lot of standard practice questions we have solved, and one gate pyq also we have done. In this lecture, mainly we need to study these topics: S attributed SDD, L attributed SDD, evaluation of SDD using dependency graph, circular SDD, and also all the gate PYQs based on these concepts. Okay, so let's start. First, we will do a quick recap of synthesized and inherited attributes. This concept we will quickly revise, and then some important point I will discuss, or I can say some alternative ways of writing the definition of synthesized and inherited attribute that we will see. Okay, one definition we have already seen, but there are alternative ways of writing the same definition. The same definition you can write from the past tree node point of view. The same definition you can write from the production point of view. Okay, so these alternative ways of writing the definition of synthesized and inherited attributes, that also we will see. Okay, so let's start with the revision of this fifth point, and we will continue the discussion of this fifth point first. Okay, so let's start. So let's do a quick recap of the definition of synthesized attribute and the definition of inherited attribute that we've already seen in the previous lecture. So let's see. So in the previous lecture, I told you that there are two kind of attributes associated with non-terminals. Right now, we will discuss the attributes for non-terminals, but I will also tell you, after some time, I will also tell you about attributes associated with terminals. Okay, so right now let's focus on attributes for non-terminals. So basically there are two type of attributes associated with non-terminals: synthesized attributes and inherited attributes. Let me tell you one more thing, that for any non-terminal, the synthesized attributes and inherited attributes, these are disjoint sets. Means for any particular non-terminal, any attribute of that non-terminal will be either synthesized or it will be inherited, but it cannot be both. Okay, for any non-terminal, same attribute cannot be both synthesized and inherited. Either it will be synthesized or it will be inherited, but not both. Okay, so you can see that if ax is the set of attributes associated with non-terminal x, with every non-terminal we associate a finite set of attributes. Okay, so let ax be the finite set of attributes associated with non-terminal x. Then remember this ax I can divide into two parts, two disjoint set. I can say this ax I can divide into two disjoint set. One is sx, which is the synthesized attributes of x, and another is ix, which is the inherited attributes of x. Okay, so very simple. This ax, which is the finite set of attributes for non-terminal x, this ax consists of two disjoint set, possibly empty. Remember, it may be possible that for this non-terminal x we don't have any synthesized attribute, or it may be possible that for this non-terminal x we don't have any inherited attribute. So you can see the set of inherited attributes, or I can say the set of synthesized attribute, they can be empty for non-terminal x. Okay, but they will be disjoint. So you can see ax consists of two disjoint set, possibly empty, sx and ix, which are synthesized attributes and inherited attributes of this non-terminal x respectively. Okay, very simple. So this is the point I was telling you, that a non-terminal can have some synthesized attributes, some inherited attributes, but for any non-terminal, a particular attribute will be either synthesized or inherited, but not both. Okay, so basically each attribute of a non-terminal will play exactly one role. It has exactly one role, either synthesized or inherited, but not both. Okay, so this is the first point for synthesized attributes and inherited attributes of a non-terminal x. Okay, now let's see the definition, the simplest definition of synthesized and inherited attributes. So this definition actually we have already seen in the previous lecture. So let me quickly revise this definition. We have already seen in the previous lecture that with each production, a set of semantic rules are associated. Okay, with every production, a set of semantic rules, rule 1, rule 2, rule 3, like that. So a set of semantic rules are associated. Now you consider this production where a is the head and this x1 to xn, this is the body. Okay, in any production, this is the complete production. In this production, this a is the head and this x1 to xn, this is the body. Means in any production, the LHS is the head and the RHS is the body. Okay, so you consider this production. With this production also, a set of semantic rules will be associated, and what these semantic rules will do, they will compute, they will define attribute, yes or no. So now let's see that if I write a semantic rule associated with this production, and in that semantic rule, if I define any attribute of LHS, then that will be called synthesized attribute. And corresponding to this production, if I write a semantic rule, in that semantic rule, if I define any attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. Okay, this is the definition that we have already seen. Let me quickly write it in the mathematical way. So you can see, consider this production A going to x1 to xn, where this A is the LHS and these are the symbols on the RHS. Now, corresponding to this production, what I'm doing, so remember, for this production, let me write it here. For this production, if I write a semantic rule, where I compute any attribute of LHS, then that attribute will be called synthesized attribute. So you can see, for this semantic rule, for this production, if I write a semantic rule, if I write a semantic rule, okay, I'm writing a semantic rule where I am computing any attribute of LHS. Okay, so A dot A, okay, where this A is the attribute of A. So you can see what I'm doing. I'm computing an attribute of A. Okay, well, let me write it T, no problem. So you can see A dot T. Now, in this semantic rule, I am computing attribute of LHS. Attribute is T of A. Okay, so you can see, for this non-terminal, this T is the attribute. This is I am computing. And remember, I can compute this attribute in terms of what? Means this attribute I will compute in terms of, or I can say as a function of, attributes of symbols in this production. Okay, so remember, this A dot T I can compute in terms of A dot A1, which this A1 is some attribute of A. So this A dot T I can compute in terms of attribute of A, attribute of these symbols. Basically, this A dot T I can compute, I can define in terms of attributes of these symbols in this production. I cannot use any symbol which is not in this production. Okay, so to compute this A dot T, to compute this attribute, I can use any attribute of these symbols in this production. So you can see, this A dot T will be computed, will be defined as a function of A dot A1, or let's say A dot A. Then you can see x1 dot A1, x2 dot A2, and so on, xn dot an. Okay, so very simple. And of course, constants also. Okay, so let me also write that constants also are allowed. So constants are also allowed. So let me write that also. So you can see dot 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 xn dot an comma constants. Okay, I hope you understood this point. So very simple. For this production, corresponding to this production, if I write a semantic rule where I compute any attribute of LHS, means I am computing attribute of this LHS, and this attribute I am computing in terms of attributes of the symbols in this production. So you can see, this attribute I am computing in terms of attributes of A, attributes of x1, attributes of x2, and so on, attributes of xn, also constants. Okay, constants are also allowed. So in this situation, because I am computing attribute of LHS, this A is the LHS, and you can see in this semantic rule for this production, I am computing attribute of LHS. So this attribute will be called synthesized attribute of LHS. Means here remember, here I can say that this is attribute of LHS, right? Okay, so you can say this is attribute of LHS that we are computing. This is attribute of LHS that we are computing. So here, this will be called synthesized attribute of LHS. Okay, this will be called synthesized attribute of LHS. Okay, so remember this T will be synthesized attribute of LHS. Is this clear? Let me know. So remember, I will say that T is synthesized attribute of LHS. T is synthesized attribute of LHS. Is this point clear to everyone? Tell me. Now let's see. For this production, if I write a semantic rule, if I write a semantic rule in which I compute any attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. Okay, so you can see if I compute xi dot t, if I compute xi dot t, okay, so you can see what is xi. Xi is a non-terminal on the RHS. So you can see if I compute any attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. So you can see this xi dot t I am computing. Remember, in terms of what? In terms of any attribute of any symbol in this production. Okay. So you cannot use any attribute of any symbol which is not present in this production. So you can see this xi dot t we are computing. This attribute we are computing in terms of attributes of symbols in this production. So you can see this xi dot t I'm computing as a function of a dot a, x1 dot a1, x2 dot a2, and so on, xn dot an, comma constants. Okay, constants are also fine, allowed. Is this clear? So now you can see that in this semantic rule for this production, this semantic rule that I am writing here, I am computing an attribute of a non-terminal on the RHS. So this attribute will be called this will be called inherited attribute of that non-terminal. Okay, so you can see that here this is the attribute of a non-terminal on RHS. Okay, in simple words, let me write attribute of RHS. Okay, so you can see this is attribute of RHS, or I can say attribute of a non-terminal on the RHS. So here this will be called what? So here we will say that this T is inherited attribute of xi. Okay, is this clear? T is inherited attribute of xi. I hope you understood. Okay, so very simple definition. You can see mathematically I have written this definition, and I hope it has cleared if there was any confusion about synthesized attribute or inherited attribute. Okay, I hope it is clear. So you can see for this production, if we write a semantic rule where we compute, where we define any attribute of LHS, that will be called synthesized attribute. And for this production, if I write a semantic rule where I compute, where I define any attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. Okay, very simple. And remember, in both the cases, whether synthesized attribute or inherited attribute, in both the cases, this attribute that you are computing, you can compute it in terms of attributes of symbols in this production, or you can use constants. Okay, that's it. I hope you understood. So now you can see the definition here. Consider this production. Corresponding to this production, if we write a semantic rule defining an attribute of this LHS, you can see if we write a semantic rule defining or computing an attribute of the non-terminal on LHS, means this A, then that will be called synthesized attribute of A. Then this is the definition of inherited attribute of X. You can see corresponding to this production, if we write a semantic rule defining an attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. Okay, and remember, in both the cases, you can see in both the cases, whether you compute, whether you define synthesized attribute or whether you define inherited attribute, then in both the cases, remember, the attribute that you are defining, you can define in terms of attributes of symbols in this production. Okay, very simple. Or you can use constants. Okay, I hope you understood. Now, we have already seen the definition of synthesized attribute, the definition of inherited attribute, and a lot of practice we have already done in the previous lecture. Many standard questions taken from standard resources, those we have already solved in the previous lecture. Now, what we will see some alternative ways of writing the same definition. Okay, the definition of synthesized attribute that we have seen, this definition we can write in different ways. The same definition we can write in different ways, so you can use any definition. Okay, but let's see all the definitions, so that in the gate exam, if they ask you some theoretical questions, some true false questions, then you can handle it. Okay, otherwise, if they give you some SDD, if they give you some syntax directed definition SDD, they give you, and they ask you what are the inherited attributes of this non-terminal, what are the synthesized attributes of this non-terminal, then that you can find with the help of our previous definition. Okay, but if there is a true false question asking you the definition of synthesized attribute, asking you the definition of inherited attribute, then these alternative definitions we can use. Okay, and these are also very easy. Okay, so let's see synthesized attribute definition. We will see from a productions point of view. Actually, from a productions point of view, we have already seen the definition that we have seen so far, that is basically from productions point of view. We will also see the definition from parse tree node point of view. Okay, from a node's point of view, also this synthesized attribute we can define. We will see that definition also. So let's see the first definition that we have already seen. So you can see this is simplest definition of synthesized attribute we have already seen. We already know that in any SDD, in any syntax directed definition, every production is associated with a set of semantic rules. So you consider this production where A is the LHS and where X1 to Xn, these are the RHS. So you can see in this production, A is the head and this RHS, this is the body. So consider this production. Now, corresponding to this production, if I write a semantic rule defining any attribute of LHS, then that will be called synthesized attribute of LHS. Okay, and you can see one more thing, that the semantic rule, or I can say the function which is defining the attribute of A, that can use attributes of any symbols in this production. Okay, so you can see that the function or the semantic rule which defines any attribute of A can only use attributes of grammar symbols in this production. So you can see it can only use attributes of any symbols in this production, including attributes of A. You can use attributes of A to define attributes of A, that is perfectly fine. Okay, that is allowed. Is this clear? To define attribute of A, you can use any attribute of any symbol in this production. So you can use attribute of A also. So you can see including attributes of A also you can use, or you can use constants. So this is the definition of synthesized attribute from productions point of view. Okay, so you can see definition from production point of view. We have already seen the same definition. I can rephrase, I can say, okay, I can just change the words and I can rephrase like this. So let's read this also. So let's read this definition of synthesized attribute. This is same as the previous definition. So let's see. You can see, consider this production. With this production, a set of semantic rules will be associated. For this production, we will write a set of semantic rules. And these semantic rules, what they will do? They will define, they will compute the attributes. Okay. So you can see, what is synthesized attribute? An attribute of the grammar symbol on the LHS means A. Remember, corresponding to this production, if I define any attribute of LHS, that will be synthesized attribute. So you can see, what is synthesized attribute? Synthesized attribute is basically an attribute of this non-terminal on the LHS, and it is computed only using attributes of symbols in this production, including the attributes of A itself and also using constants. Okay, this is the definition of synthesized attribute. So you can see, what is synthesized attribute? Synthesized attribute is an attribute of grammar symbol on the LHS, means attribute of A computed only using the attributes of grammar symbols on the RHS, also attributes of A. So you can see that it is computed only using attributes of grammar symbols on the RHS and using attributes of A. So in one line I can say that this attribute of this LHS you are computing using attributes of symbols in this production, okay, and using constants. Very simple. So you can see, in other words, if this A going to alpha, if this is a production, then what is A's synthesized attribute? A's synthesized attribute are determined only by attributes of the symbols in alpha and attributes of A and constants. Okay, so overall I can say that synthesized attribute of A dot T, A dot T, where T is the synthesized attribute of A. So you can see, corresponding to this production, if I define any attribute of LHS, that will be synthesized attribute of LHS. So you can see, I can compute this A dot T, which is the synthesized attribute of A. I can compute it only using attributes of symbols in this production. So I can say this A dot T, I can write it as a function of, I can compute this in terms of A dot A, x1 dot A1, x2 dot A2, okay, and so on, xn dot an, comma constants. Okay, that's it. Very simple. So here this will be called, here we will say that T is synthesized attribute of, T is synthesized attribute of A. Okay, T is synthesized attribute of A. I hope you understood. Okay, the same thing is written here. You can see each production is associated with a set of semantic rules. So consider this production where A is the LHS. So what is synthesized attribute? An attribute of A. I told you synthesized attribute means the attribute of LHS. Okay, so you can see an attribute of A computed using attributes of x1, x2, xn, comma A and constants. Okay, so you can see an attribute of A computed using attributes of A, comma x1, comma x2, comma xn. Okay, and constants. For example, you can consider this is the production, and with this production, corresponding to this production, this semantic rule we have written. So in this semantic rule, we are defining an attribute. Tell me, we are defining attribute of LHS or are we defining attribute of a non-terminal on the RHS? Let me know. So here you can see that we are defining attribute of E0. This is E0. Okay, remember E0, E1, they are basically same variable, different instances. Okay, same variable, different instances. But you can see that for this production, corresponding to this production, this semantic rule that we have written, it computes, it defines an attribute of LHS. Okay, you can see this attribute VAL, this attribute of LHS E0. So this we are defining in this semantic rule. So this VAL, this is the synthesized attribute of E0. Okay, is this clear? Very simple. So you can see E0 dot VAL, this we are computing in terms of attributes of symbols in this production. You can see this E0 dot VAL, this we are computing in terms of attributes of symbols in this production. You can see we can use attribute of LHS, we can use attribute of E1, we can use attribute of T, we can use attribute of E0 also. Okay, we can use constant also. I hope this point is clear. Okay, so here you can see, I can say that here this E0 dot val, or I can say that this VAL, this is a synthesized attribute of E0. Okay, so you can see here E0, or I can say that VAL, here VAL is a synthesized attribute of E0. Synthesized attribute of E0. Okay, actually, let me tell you one thing, that this e0 even, they are basically same variable e, but different instances. Okay, so if your variable is e, then you can simply call it e. Okay, is this clear? If your variable name is e0, then you can call it e0. If your variable name is e, then you can call it e. Is this clear? So very simple. So here this val, this is a synthesized attribute of e0 or e. Okay, or e. Okay, now let's see. Now let's see the synthesized attribute definition from parse tree node point of view. Definition from a parse tree node point of view. This definition is also very simple, and you can understand this definition from the previous definition. So already we have seen synthesized attribute definition from production point of view. Now remember how this production will translate to a parse tree. Just think about this. We have already seen synthesized attribute definition from production point of view. Now, how this production will translate in a parse tree, inside a parse tree, how this production will be translated, or I can say how this production will be used inside a parse tree. Very simple. Inside a parse tree, what will happen? This A will be a node, and this A will go to x1, x2, and so on. Do you agree with me? Yes or no? X1, x2, and so on, xn. Like this it will happen. Yes or no? This production, how it will translate, how it will translate as a part of parse tree, or I can say this production, how it will be used inside the parse tree. Inside the parse tree, this production will be used like this, that A will go to x1, x2, and so on, xn. Correct? Yes or no? Now you can notice that this RHS, which is the body, now they have become the child of A. From the parse tree point of view, if you use the terminology of parse tree, if you use the tree terminology, then you can see that this x1 to xn, now these are the child of A. Yes or no? So you can see, so far we were calling it head. Okay, in this production, this A, you can call it head, but now I can also call it parent. Yes or no? From x1 to xn point of view, this A is the parent. Yes or no? So I can also call it parent. And you can see this RHS of the production, these symbols on the RHS, this RHS is your body. This is the body of the production. And I can also call them children. I can also call them children. Yes or no? In the tree terminology, I can call this A parent, and this x1 to xn, I can call them children. Now, you can see this is how this production will be used inside a parse tree. And now, very simple. Remember, I told you the definition of synthesized attribute from production point of view, that for this production, corresponding to this production, if I write a semantic rule computing any attribute of LHS in terms of attribute of symbols in this production, then that will be called synthesized attribute of LHS. Yes or no? Okay, so here you can see this, we already know that if I compute an attribute of A dot T, if I compute an attribute of A, attribute of LHS, I am computing in terms of, as a function of attributes of symbols in this production, means A dot A, x1 dot a1, x2 dot a2, and so on, xn dot an, and constants also are allowed. Okay, so here you can notice one thing, that basically what is happening, the information is flowing from children to parent. Do you agree? Tell me, in a synthesized attribute, just tell me this simple point I'm asking. In a synthesized attribute, the information will flow from parent to children or from children to parent? Tell me, the information will flow bottom up or top down? The information will flow bottom up. Yes or no? Because remember, this attribute of A, we are computing from attributes of x1 to xn. So you can see, to compute the attribute of A, to compute the value of attribute of A, we need the values of attribute of x1 to xn. Yes or no? because you can see we are writing attribute of A. We are computing attribute of A as a function of, or I can say in terms of attributes of symbols in this production. Means attribute of A we are computing in terms of attributes of these children. Yes or no? So you can see that first we need to know the attribute values of these children, then we can compute the attribute value of this parent. Yes or no? Is this clear? So you can see that in a synthesized attribute, what happens? In a synthesized attribute, the information flows bottom up. Do you agree with me? The information will flow bottom up. The information flows bottom up. You can see this is the flow of the information. That information is flowing bottom up. This is the information flow. Okay, is this point clear? Let me know. Very simple point, because we are computing attribute of parent using attributes of children. So I can say that using synthesized attributes, the information will flow bottom up. The information flows from children to parent. Okay, very simple. And one more thing, you can see that synthesized attribute of this non-terminal A, we can compute, we can define in terms of attributes of children, also attributes of this node itself, attributes of this non-terminal itself, and also using constants. Okay, that same thing is written here. You can read this, that a synthesized attribute, okay, you can see a synthesized attribute for a non-terminal A is defined, is computed only in terms of attributes of A children, attributes of A itself, and constants. Means the synthesized attribute of this A I can define in terms of attributes of children, in terms of attributes of A, and also in terms of constants. Okay, is this clear? So this is the synthesized attribute definition from parse tree node point of view. I hope you understood. Also, I hope you understood that using synthesized attributes, if you are using synthesized attributes, then the information will flow bottom up. Okay, the information will go from children to parent. First you compute the information for children, then you compute information for parent. Means first you compute attributes for children, then you compute attributes for parent. Okay, so the information is flowing bottom up. Okay, I hope you understood. Very simple. So everything that I told you, that is written here, you can read this, that using synthesized attributes, the information flows bottom up. Means the information goes from children to parent of the parse tree. Okay, the information flows from children to parent. The information flows bottom up. Very simple. Okay, so you can see that synthesized attributes are those attributes that are passed up a parse tree. The synthesized attributes are basically passed up a parse tree. Means the synthesized attribute, they go from children to parent. Okay, we compute the synthesized attribute from children to parent. So that is what is written here, that synthesized attributes are those attributes that are passed up, that are passed up a parse tree. Okay, very simple. You can see the left side attribute is computed from the right side attributes, the attribute of itself and constants. Okay, this is the definition of synthesized attribute we have already seen. Okay, you can see the lexical analyzer usually supplies the attributes of terminals. This we have already seen in the previous lecture. I told you that for terminals, the attribute values are supplied by the lexical analyzer. Okay, for non-terminals, the attribute values we can compute with help of semantic rules. So to compute the attributes of non-terminals, we write semantic rules, but we cannot write semantic rules to compute attribute values of terminals. For terminals, the attribute values are always supplied by the lexical analyzer. Okay, that is written here. You can see the terminals get their attribute values directly from the lexical analyzer. Okay, means the lexical analyzer will supply the attribute values of terminals. Okay, and you can see the synthesized attributes, they are built up, they are built upwards. Okay, means from children to parent. So you can see they are built up for non-terminals and they are passed up the tree. Okay, up the tree. Very simple. Now let's consider one example. So one example I will take for synthesized attribute evaluation. Okay, so you can see this is synthesized attribute evaluation example. Because remember, if we are using synthesized attributes if we are only using synthesized attribute in our SDD, if all the attributes are synthesized attribute, then we already know that synthesized attribute, using synthesized attribute, the information flows bottom up. Okay, the information goes from children to parent. Okay, this we already know. So let's consider one example here. You can see this is the SDD that is given to you. So first you understand this SDD. Here, this int, this is the start variable. Okay, this int1, int2, these are basically same variable, different instances. So you can see this int can go to digit, or this int can go to int followed by digit, and this digit can go to 0 to 9. Okay, and you can see with these productions, semantic rules are also associated. These semantic rules will tell you how the attributes will be computed. Okay, you can see that for these non-terminals, int comma digit, for these non-terminals, we are associating this value attribute. Okay, this value attribute is associated with these non-terminals, int comma digit. You can see that, let's focus on this production, digit going to 0, and this is the semantic rule associated with this production. Here you can see digit dot value equal to 0. Okay, means for this production, corresponding to this production, this is the semantic rule associated, and here we are computing attribute of LHS. So tell me, this attribute value, this is synthesized or inherited attribute of digit? Tell me, this is synthesized attribute of digit, yes or no? Because you can see that you can check all these productions, you can check the productions of digit, you can check, and in these productions, or I can say in the semantic rules for these productions, you can see that we are computing the attribute value, this value attribute we are computing of LHS. So you can see this value attribute, this is basically synthesized attribute of digit. Okay, yes or no? So very simple point that here you can see that. So clearly I can say clearly this value attribute, this is synthesized attribute of digit. Okay, so you can see value attribute, you can see this value attribute is synthesized attribute, is synthesized attribute of non-terminal digit, of non-terminal digit. Okay, is this clear? Very simple. Now let's see for this int also, this is another non-terminal. You can see for this int there are two productions, for this int there are two productions, and these are the semantic rules associated with these productions. So you can see in these semantic rules, you can see, for example, consider this production. Corresponding to this production, this is the semantic rule. In this semantic rule, we are computing the value attribute of LHS. So you can see this value attribute, this is a synthesized attribute of int. Here also you can see in this production also you can see this is the semantic rule associated, and in this semantic rule also you can see we are computing the value attribute, we are computing for LHS. Okay, so you can see that here also the attribute of LHS we are computing. So this value attribute, this is basically synthesized attribute of int. Okay, yes or no? So very simple point that this value attribute, this is synthesized attribute of non-terminal digit, comma, I can say that this value attribute, okay, this value attribute, this is synthesized attribute of non-terminal digit, comma, non-terminal int. Okay, basically I can say that in this SDD, we only have synthesized attribute, there is no inherited attribute, yes or no? So you can see that, you can see that in this SDD, in this SDD, all attributes, actually there is only one attribute, that is value. This is the only attribute that we are using for all the non-terminals. So you can see, I can say that this value attribute is synthesized, or I can say that all attributes in this SDD are synthesized. All attributes are synthesized. All attributes are synthesized. Okay, and there is one good thing about synthesized attribute. What is that? That using synthesized attributes, the information flows bottom up. The information flows from children to parent. Means first you compute information for the children, then you compute information for the parents. Okay, so the information will go bottom up. Okay, up the tree, like that. Okay, now the question is saying that this input 42 you have, for this input you find what will be the output, or I can say what will be the int dot value. Okay, this is what we need to calculate. So you can see this is the input. Now what we need to do, we need to find output. Okay, means we need to find int dot value. We need to find int dot value for root of the parse tree. Root of parse tree. Okay, this is what we need to find. Now we can easily find it. So what we will do, first you make the parse tree. Okay, this is very easy. Synthesized attribute evaluation, this is extremely easy. What we will do now, first we will make the parse tree. Okay, so let's make the parse tree. For the parse tree, the root node will be the start variable. Start variable is int. Remember, int1, int2, they are basically same variable, different instances. Okay, so you can see this int1, this int2, these are basically same variables, different instances. Same variable, different instances. Basically, just to differentiate between this int and this int, to differentiate between them, we are using this subscript 1 comma 2. Okay, but actually they are basically same variable. When I say same variable means basically the variable is int. Okay, the same variable, the variable is int, and these are different instances of that variable. So int1, int2, this subscript we are using to differentiate between these two int. Okay, very simple. So you can see, let's make the parse tree. So in the parse tree, this int will go to, I want 42, so int will go to int comma digit. Okay, int will go to int comma digit. Int comma digit. Next you can see what I want. I want 42. So this digit can go to 2. Okay, and this int will go to digit. This int will go to digit, and this digit will go to 4. Okay, yes or no? Very simple. So this parse tree we have made. Now once the parse tree is done, now you can easily see that all these attributes, these are basically synthesized attributes, and using synthesized attributes, the information will flow bottom up. Okay, so you can see, look at this production. Okay, look at this digit going to 4. So digit going to 4, then tell me what will be digit value? That will be 4. Yes or no? So you can see here you can very easily compute the attribute value for this node, I can say. Okay, in this parse tree, this is the parse tree. For this node, I can easily calculate the attribute value. Yes or no? So you can see for this node, we have a value attribute. Yes or no? For this node, we have a value attribute. So tell me, for this node, the value attribute that you have, what it will become? I can say digit dot value. What it will become? It will become 4. Yes or no? Very easily you can calculate the digit dot value, or I can say for this node, you can calculate the attribute value. Okay, so that will be 4. Now, similarly, you can see here digit going to 2. Here also, you can see that for this non-terminal, or I can say for this node, in this parse tree, for this node, I can calculate the value attribute value, and that will be 2. Yes or no? So here also you can see that the value attribute value, that will be 2. Very simple, because you can see digit going to 2. So this is the semantic rule, and here the digit value, that is equal to 2. Okay, very simple. Now let's see the next. You can see now I have, for this node I have the value attribute value. For this node also I have value attribute value. Okay, very simple. Now let's see what will be value attribute value for this node. Okay, now we need to see for this node, what will be value attribute value. So you can see here which production you are using. Int going to digit. Yes or no? Int going to digit, this production we are using, and corresponding to this production, this is the semantic rule. In this semantic rule, you can see int1 dot value. Int1 is the LHS. So you can see this int dot value, that will be same as a digit dot value. So you can see digit dot value, that is 4. So what will be this int dot value? That also will be 4. Yes or no? So you can see for this node, the value attribute value, that will be 4. Did you notice one thing? That information is flowing upward. Yes or no? You can see that the information is flowing upward like that. This information is going like this. Okay. From here, we have found the attribute, we have found the value attribute value for this node. Then you can see from this node, or I can say from the attribute value at this node, we have found the attribute value at this node. So the information is flowing upward. Okay, here also you can see that information was flowing upward. Very simple. Now what we have, now we have value attribute value for this node, also value attribute value for this node. Basically attribute value at this node, attribute value at this node we have. So now we can find the attribute value at this node. Okay, so you can see which production we are using here, int going to int digit. Okay, int going to int digit, and this is the corresponding semantic rule. Here you can see int1 dot value, int1 is the LHS, means this int dot value, this will be equal to int2 dot value into 10. Okay, so remember this is int1 LHS and this int2 is the RHS. So you can see that int1 dot value means int dot value, that will be equal to 10 multiplied by this plus this. Okay, means 10 multiplied by int dot value plus digit dot value. Very simple. So you can see that we already have int dot value, we already have digit dot value, so we can find this int dot value very easily. Okay, so you can see the information is flowing upward. Using synthesized attributes, the information will flow upward. So here you can see that for this node, what will be the value? That will become 4 into 10 plus 2. Okay, 4 into 10 plus 2. Ultimately, what we got? We got 42. Okay, is this clear? I hope you understood this. Very simple, right? So you can see using synthesized attributes, the information is flowing upward, means the information is flowing bottom up. The information is flowing from children to parent. Okay, so you calculate, you compute the attribute values for children, then from that you can calculate the attribute values for parent. So using synthesized attribute, the information flows bottom up. Okay, very simple. I hope you understood. Okay, I can give you a homework here. So let's assume that the input is, let's assume 302. Okay, now, okay, just for practice sake, I know you understood what will be the output. The output again will be 302, but just for practice sake, just for sake of practice, what you do, you make parse tree and then you do the evaluation bottom up. Okay, because all the attributes are synthesized attributes, so the information will flow upward. Okay, so you can just take this as a homework. Okay, just for sake of practice, you can do it. Okay, make the parse tree and then you see how the evaluation will happen. The information will go from children to parent. Okay, very simple. I hope you understood. So basically this was our example. Okay, this we have already seen. You can see. Okay, this was the parse tree and we have calculated for the root node what will be the value attribute value. Okay, so that will be 42. So this we have already seen. Now let's move on. So finally, this is what I told you, that using synthesized attributes, the information will flow upward, or I can say the information will flow bottom up. Okay, from children to parent. Okay, so you can see, like you can see that the synthesized attributes, using synthesized attributes, the information is flowing bottom up. One more thing you can see, for the terminals, the attribute values will be supplied by the lexical analyzer. Okay, that is what I've written here. You can see. Okay, if this num, if this is the terminal, then you can see for terminal the attribute values will be supplied by the lexical analyzer. So that is what I've written here. Okay, very simple. And then you can see for the non-terminals, like these are the non-terminals. For the non-terminals, we can compute the attribute values with help of semantic rules. Okay, very simple. Now let's see one important note about attributes of terminals. I told you that first we will discuss about attributes of non-terminals. Then I told you that we will also discuss about attributes of terminals. Okay, so far we were discussing attributes of non-terminals, the synthesized attribute definition, the inherited attribute definition. These we have seen for non-terminals. Okay, now let's see one important note about attributes of terminals. So this is a very simple note. Let me tell you that all the attributes of terminals are always synthesized. attributes of terminals are never inherited. All the attributes of all the terminals, these are always synthesized. Okay, these are assumed to be synthesized. These are classified as synthesized. Okay, is this clear? Very simple point, that attributes of terminals are always assumed, are always classified as synthesized attributes. One more thing, to compute the attribute values of terminals, we do not write semantic rules. I told you that attribute values of terminals are always supplied by the lexical analyzer. Okay, so we do not write any semantic rule to compute the attribute values for terminals. Okay, the attribute values for terminals, these are always supplied by the lexical analyzer, and attributes of terminals are classified, are assumed always as synthesized attributes. So terminals never have inherited attributes. Very simple point. This is what I've written here. So you can see attributes of terminals are always classified, are always assumed to be synthesized attributes only, not inherited attributes. So I can say that terminals never have inherited attributes. All the attributes of terminals are always synthesized. Okay. Also, this point we have already seen that terminals have synthesized attribute but not inherited attributes. This we have seen. Also, the attributes for terminals have lexical value that are supplied by lexical analyzer. There are no semantic rules in the SDD itself for computing the value of attribute for a terminal. Okay, for a terminal to compute the value of any attribute in the SDD, there is no semantic rule, because the attribute value for terminals are supplied by the lexical analyzer, and terminals have synthesized attribute, not inherited attribute. Okay, so that's it. This is about attributes of terminals. I hope you understood. Now let's discuss alternative ways of writing the definition of inherited attribute. Already we have seen inherited attribute definition. In the previous lecture, a lot of practice we have done. Now let's see alternative ways of writing the same definition. So from the production point of view, the definition actually we have already seen. We will also see from a parse tree node point of view. Okay, so let's see this definition, the simplest definition of inherited attribute that we have already seen. We already know that in any SDD, for each production, we associate a set of semantic rules. So now you consider this production where A is the LHS and X1 to Xn, these are RHS. Okay, so you can see this is your production. Now, corresponding to this production, for this production, if I write a semantic rule which defines, which computes any attribute of any non-terminal on the RHS, then that will be called inherited attribute of that non-terminal. Okay, and also remember, when we compute the attribute of non-terminal on the RHS, when we compute the attribute, then remember we can compute that attribute in terms of attributes of symbols in this production, including attributes of that non-terminal itself. Okay, so you can see this here, that the semantic rule or the function which defines the attribute A of non-terminal X, attribute A of non-terminal X on RHS. So X is a non-terminal on the RHS. Now, the semantic rule, the function which defines the attribute A of non-terminal X on the RHS can only use the attributes of any symbols in the production, including attributes of X and constants. Okay, very simple. So I hope you understood. Now you can see the same definition, the same previous definition, we can rephrase. Okay, because I told you in this production, remember, this A is the head, LHS is the head, and this RHS is the body. Also, I told you that in the tree terminology, okay, using parse tree terminology, you can see this A, this is basically the parent, and I can say these are the children. So you can see inherited attribute, an attribute of non-terminal that gets its values from attributes attached to parent or siblings or itself or constants. Okay, so you can see, let me write here. You can see that corresponding to this production, okay, this definition we have already seen. Corresponding to this production, if we write a semantic rule computing an attribute of a non-terminal on the RHS, that will be called inherited attribute. And to compute that attribute, we can use attributes of any symbol in this production. So basically I can say that xi dot t, okay, means This xi, this is a non-terminal on the RHS, and this t is the attribute. Now, if I compute this t attribute of xi, okay, in terms of attributes of symbols in this production, then you can see this attribute will be called inherited attribute of xi. Okay, so you can see here I can write that this attribute of xi we can compute as a function of attributes of symbols in this production. So a dot a, x1 dot a1, x2 dot a2, and so on, xn dot an, okay, comma constant. Okay, constants are also fine. So here in this situation we will say that this t is inherited attribute of xi. Okay, so t is inherited attribute of xi. Okay, very simple. I hope you understood. Now let's come back to this definition here. You can see what is inherited attribute. This is attribute of a non-terminal that gets its values from attributes attached to the parent, attributes attached to the siblings, attributes attached to itself, and constants. Okay, so this is the definition of inherited attribute. So you can see inherited attribute means an attribute of a non-terminal that gets its value from attributes of parent, from attributes of siblings, okay, and from attributes of itself and attributes of and constants. Okay, so very simple. I hope you understood. Now, actually, this is basically the definition from past tree node point of view. Okay, so don't worry, we will come to that. Okay, so I hope you understood this point. That basically you can see here what we want to say. We want to say that xi dot t. Okay, this is inherited attribute of non-terminal xi, and this can get its values from where? This can get its values from attributes attached to parent. Okay, means a dot a. Attributes attached to siblings means, for example, x1 dot a1, x2 dot a2, like that. Okay, attributes attached to itself means xi dot ai. Okay, and so on, and so on, xn dot an, and constants. Okay, constants. So that's it. I hope you understood. So here this t will be inherited attribute. Okay, so here I can say this t is inherited attribute of xi. Okay, so let's move on now. Now you can see this here, that this is the production. Let's assume this is the production, and for this production, corresponding to this production, we are writing semantic rule. In that semantic rule, we are defining an attribute of a non-terminal on the RHS. So you can see an attribute of a symbol on the RHS, an attribute of a non-terminal on the RHS computed using attributes of a, attributes of x1, attributes of x2, attributes of xn, and constants. So that is the inherited attribute definition. You can consider this example, that this is the production decl, this is a non-terminal going to this capital T. Okay, remember type. Okay, so this type, this is this L, these are basically non-terminals. So you can see this D is going to TL. You can, you for a moment you can assume like this, that this is basically D and this is T, and like this. Okay, so you can see like this, because notice one thing, that actually notice one thing, that this small t, type with small t, that is basically attribute, and type with capital T, that is basically non-terminal. Okay, is this clear? So now let's see. So let's assume this is the production D going to TL semicolon. Now you can see for this production, this is the semantic rule that we have written. In this semantic rule, we are computing, we are defining this type attribute for L. And you can see this L is non-terminal on the RHS, yes or no? This L, this is non-terminal on the RHS. So here basically in this semantic rule, we are defining an attribute of RHS. So this is inherited attribute of L. So remember this type, this is an inherited attribute of L. I hope you understood. One more thing you can notice, that this attribute that you are computing, that you are defining, okay, this you are defining in terms of attributes of symbols in this production. You can see in this production we have this T. Okay, yes or no? So you can see that this attribute that you are defining in terms of attributes of symbols in this production. So you are using attribute type of this T. Okay, very simple. You can consider this example also. We have production L0 going to L1 comma ID. So this is the production, and you can see this is the semantic rule associated with this production. In this semantic rule we are defining L1 dot type, this type attribute of L1 we are defining, and you can see this L1, this is on the RHS. So basically in this semantic rule we are defining attribute of RHS. So this is a inherited attribute of L1. So remember this type, this is inherited attribute of L1. One more thing you can notice that this attribute we are defining in terms of attribute of symbols in this production. Okay, yes or no? So you can see that this L1 dot type we are defining in terms of L0 dot type. Okay, I hope you understood. So basically in both these examples, in these semantic rules we are defining attribute of a non-terminal on the RHS. That is the reason that attribute is inherited attribute of that non-terminal. Okay, and we are defining in terms of attribute of other symbols in the production itself. Okay, very simple. Now let's see inherited attribute definition from parse tree node point of view. So again I will ask you the same thing, that consider this production. From the production point of view, the inherited definition you already know. Now you tell me how this production will appear inside the parse tree, how this production will translate inside the parse tree. Very simple. Inside the parse tree what will happen? It will happen that a is the parent. Okay, and this a will go to x1, x2, and so on xn. Yes or no? So you can see this production will look like this in the parse tree. So you can see in the parse tree terminology I can say that this a is basically the parent and these are basically children. Okay, now we want to find the definition of inherited attribute from parse tree node point of view. So tell me one thing, to define inherited attribute from parse tree node point of view, for which non-terminal, for which symbol we should compute the attribute value? Should we compute the attribute value for a? No. If we compute the attribute value for a, that will be synthesized attribute. I want to define inherited attribute. So you can see that very simple, that we need to define an attribute value of a child. Yes or no? An attribute value of a child. So very simple. Here I can say that xi dot, okay, or for example let me use x2. Okay, for example x2 dot t, that we are writing in terms of a dot a, x1 dot a1, x2 dot a2, and so on xn dot an comma constants. Okay, so here you can easily see that this x2 dot t, this is inherited attribute. Okay, yes or no? This is inherited attribute. So remember, for this node, okay, in this parse tree, for this node we are calculating the t attribute value. Okay, yes or no? For this node the t attribute value we are computing. So tell me a very simple thing I am asking. We are computing t attribute value for this node x2, and for this computation the information is flowing in which direction? You can see, to compute the t attribute value for this node we can use attribute of parent. Yes or no? We can use attribute of parent, we can use attribute of sibling from left to right, we can use attribute for sibling from right to left. So did you notice that using inherited attribute the information flows left to right, right to left, and top down, not bottom up? Do you agree with me that using inherited attribute the information flows top down, from parent to child, from sibling left to right, from sibling right to left? So the information flows from sibling right to left, from sibling left to right, and from parent top to down. But the information does not flow upward. The information does not flow in the upward direction. The information flows in the downward direction or left right, left to right, right to left from siblings. I hope you understood this point. Very simple. So you can see this is what I've written here. An inherited attribute at node n. Remember, this is the node n because we are finding inherited attribute of x2. So you can see an inherited attribute at node n. This is the node n. So an inherited attribute at node n is defined only in terms of attribute values at the parent of n itself, its siblings, and constants. Okay, this is what we have written here. I hope you understood this definition. Okay, so very simple. Let me again tell you this point that using inherited attributes, the information will flow top down from parent to child and left to right, right to left from siblings. This is an important point. Okay, I told you that using synthesized attributes, the information flows bottom up from children to parent. But using inherited attribute, the information flows top down from parent to child, left to right from siblings, right to left from siblings. Okay, very simple. So this is what is written here. You can see that using inherited attributes, information flows top down from parent to child and from siblings left to right, right to left. Okay, so you can see inherited attributes are those attributes which are passed down a pass tree. Okay, means the information flows top down, left to right, right to left, like that. Okay, very simple. So I can make one diagram actually just to make it clear. Okay, so you can see how the information flows. How information flows. How information flows. So using synthesized attributes, how the information flows. And using inherited attributes, how information flows. Okay, so notice that using synthesized attributes, the information flows from child to parent. Okay, means the information flows bottom up. The information flows upward. Okay, yes or no? From children to parent. Okay, so you can see the information flows bottom up, upward. Very simple. Upward flow, I can say. Okay, and you can see using inherited attributes, the information flows from parent to child, from siblings left to right, from siblings right to left. Okay, is this clear? So like that, I hope you understood. So very simple, this is the whole point. Okay, so means from parent to child, from siblings left to right, from sibling right to left. Okay, I hope this is clear. Okay, in one word, people just write it top down flow. Okay, people write it top down flow, but actually it is basically top down, left to right also, right to left also, top down also. Okay, in one word, people they just simply call it top down flow, but you can call it, okay, if you want to be very accurate, then you can say that flow is top down flow, left to right flow, right to left flow. Okay, top down flow, left to right flow, right to left flow. Top down means from parent to child, and left to right means from sibling, right to left means from sibling. Okay, very simple. I hope you understood. You can consider this example here. In this example, do we have inherited attribute? Do we have synthesized attribute? So this example actually we have already seen in the previous lecture. You can see that, look at this production. For this production, these are the semantic rules associated, and in this semantic rule you can notice that we are defining attribute of b. This b is on the LHS. We are defining attribute of LHS. So this POS, this is actually synthesized attribute of b. Similarly, in this semantic rule, we are computing attribute of B. This VAL, this attribute of B, we are computing. This B is on the LHS. So we are defining attribute of LHS. So this VAL, this is synthesized attribute of B. Okay, correct? So, but notice one thing here. Okay, look at this semantic rule. In this semantic rule, we are defining attribute POW of D. And you can see this D is on the RHS. This D is on the RHS. So you can see we are defining attribute of RHS. So this is inherited attribute of D. This POW, this is inherited attribute of D. Okay, and you can see that to compute D dot POW, to compute attribute of D, we are using attribute of B1. Okay, yes or no? Very simple. So remember here, D dot POW, that is basically inherited attribute. Okay, the same thing you can see here also. Look at this production. In this production, D is on the right side. You can see these are the semantic rules associated with this production. And in this production, we are computing, we are defining D dot POW, and this D is on the RHS. So we are defining attribute of RHS. So this is inherited attribute. So POW, this is the inherited attribute of D. Okay, here you are computing this D dot POW in terms of constant. I told you constants are allowed. Okay, correct. So now overall I can say that, look at this, look at this. Here you can easily see that D dot POW, this is basically inherited attribute. Yes or no? D dot POW is inherited attribute. Okay, this D dot POW, this is inherited attribute. Now let me show you for this particular example how the information will flow for D dot POW. Okay, so you can see in the parse tree, let's assume you have this type of node. Okay, means B is going to DB1. Okay, yes or no? Notice one thing, that this B1 and this B, they are basically same variable, different instances. So you can see that this is basically your B1. Okay, let me write like this, that this is your B1. But actually this is basically B. Okay, so we will write it B going to DB. Okay, so now notice one thing, that this D, this has POW attribute. Okay, yes or no? This D has POW attribute. And you can see this B has two attribute, VAL and POS. Okay, here also you have VAL, here also you have POS, here also you have VAL, here also you have POS. Okay, yes or no? Now notice, look at this, that to compute D dot POW, we are using B1 dot POS, and this is B1. Okay, this is B and this is B1. So remember, to compute this D dot POW, basically this D dot POW, this will be same as B1 dot POS, and this is your B1. So remember, this value will pass to this. Yes or no? The information is passing from sibling right to left. Is this clear? The information is passing from sibling right to left. I hope you understood this point. Means first you calculate B dot POS. First you calculate this, then you can calculate D dot POW. Is this point clear to everyone? Very simple. So you can see the information is passing from sibling right to left. Okay. I hope this point is clear. Okay. So very simple. This is the flow of information, I can say. This is the information flow. Okay. Means what you will do, first you will calculate B dot POS, then you will calculate D dot POW. Okay. So very simple. So first we calculate B dot POS. Okay, for this B. Okay, so let me use B1 here so that there is no confusion. Okay, so remember, or I can say that first we calculate B dot POS for right sibling, right? Yes or no? B dot POS of sibling. First we calculate B dot POS for sibling. Okay, for sibling. Then calculate then calculate d dot POW. Okay, d dot POW. Okay, that's it. I hope you understood this. Okay, so this example actually we have already seen in the previous lecture, that for these non-terminals we have synthesized and inherited attributes like this. You can see for the non-terminal B, POS comma VAL. Okay, both these are synthesized attributes, but for this non-terminal D, this VAL, this is synthesized attribute, POW, this is a inherited attribute. Okay, tell me the answer for this question. An inherited attribute for a non-terminal B at a parse tree node N is defined by a semantic rule associated with the production at N, the production at parent of N, the production at child of N. Tell me what is the answer. This is an important question. From the concepts that we have seen so far, you can easily solve it. Tell me the answer. An inherited attribute for a non-terminal B at a parse tree node N is defined by a semantic rule associated with what? To solve this question, you just make a tree diagram, okay, so that you don't make any mistake. What I'm saying, notice, we are saying that inherited attribute for a non-terminal B at a parse tree node N. So this is the non-terminal B, okay, you can see, and this is the parse tree node N. Let's call it node N. So in the parse tree, this is the node N, and it contains the non-terminal B. This is what the question is saying. And you can see an inherited attribute of this B. For this B, let's assume this I is inherited attribute. So you are computing this I, which is inherited attribute of B. Okay, is this clear? This B dot I, this is basically inherited attribute. So inherited attribute, okay, let's assume that is B dot I. Let's assume that is B dot I. Okay, is this clear? So you can see for this non-terminal B, this inherited attribute is I. Okay, now you already know one thing, that if this I is inherited attribute, then tell me, if this I is inherited attribute, then tell me this will be computed, this B dot I, this will be computed in terms of attributes of siblings from left to right, from right to left, also from attributes of parent, yes or no? Let's assume the parent is A. Let's assume this is the parent. This A is the parent. Okay. One more thing you notice, that if this B dot I, if this is a inherited attribute, then see there is a production. Okay, notice one thing. There is a production for which there is semantic rule. In that semantic rule, this B dot I we are defining. Do you agree with me? Yes or no? The question is saying inherited attribute for a non-terminal B. Okay, so you can see there is some production. The question is asking that the semantic rule is associated with which production? The semantic rule which defines this inherited attribute, that semantic rule is associated with which production? This is what the question is asking. Okay, very simple point. Notice one thing. Let's assume this is the production. Let's assume this is the production. Okay, this is the production. I don't know this production has what head and what is the body. I don't know. Okay, let's assume this is the production, and with this production a semantic rule is associated, and in this semantic rule this inherited attribute is defined. Means in this semantic rule, this B dot I am defining. Okay, this B dot I, this is what I am defining in this semantic rule. Then can you tell me this B will be on the LHS of production, or this will be on the RHS of production? Tell me. See, very simple question I'm asking. Inherited attribute of non-terminal B. This is defined by a semantic rule. Okay, this is defined by a semantic rule. Let's assume that that rule is this. Okay, this is the semantic rule. Okay, so you can see this is defined by a semantic rule, and let's assume this is that semantic rule. Okay, this is that semantic rule. Is this clear? Very simple. In this semantic rule, inherited attribute of non-terminal b I am defining. Means in this semantic rule, b dot I am defining, and this I is inherited attribute. Then tell me, for this production, this semantic rule we are writing, and in this semantic rule, if inherited attribute I am defining, then this b will be on the LHS or this will be on the RHS. This if this b is on the LHS, then what will be the problem? Let's assume b is on the LHS. Let's assume b is on the LHS. Now you can see if b is on the LHS and you are computing attribute of LHS, then this will become synthesized attribute. Yes or no? Then this will become synthesized attribute. Do you agree with me? Very simple point I am saying. I am saying that if this b is on the LHS, then here in this semantic rule for this production, you are defining, you are computing attribute of LHS. Attribute of LHS. Then this will be what? Then this will be synthesized attribute of b. Yes or no? Then this will be synthesized attribute of b. Then this will become synthesized attribute. Yes or no? Then synthesized attribute b dot I. Yes or no? Do you agree with me? And the question is saying this is inherited attribute. This b dot I, this is inherited attribute. This question is saying that this is inherited attribute. Okay. And if you put this b on the LHS, then this b dot I will become synthesized attribute. I told you one thing, that for a non-terminal, any attribute will be either synthesized or it will be inherited, but not both. So remember, for this non-terminal b, this I attribute cannot be inherited as well as synthesized. Either it will be inherited or it will be synthesized, but not both. The question is saying that b dot I is inherited. Then definitely this b you cannot put on the LHS. Do you agree with me? So definitely there is a contradiction here. Please tell me, did you understand this? Very simple explanation. Tell me, did you understand this? Let me know. This is a contradiction. Okay, this is a contradiction. Yes or no? Did you understand this explanation? Tell me. So definitely I can say that this B is on the RHS. This B is a terminal on the RHS. This B is a terminal on the this B is a non-terminal. This B is a non-terminal on the RHS. Okay, yes or no? So this B is a symbol on the RHS. I can say this B is a non-terminal on the RHS. And this is A. I hope you understood. So finally, what will be the answer? Tell me. You can see for this B, this A is the parent. This is the parent of B. Yes or no? I can say this A, this is the parent of B. So now you tell me, please tell me. The question is asking that inherited attribute of non-terminal B at a parse tree node N, is defined by a semantic rule. It is defined by a semantic rule associated with which production? Associated with production of A. This is production of A because A is the head. If A is the head, then this is production of A. Then this is the production of A. Means this is the production of parent. So I can say the answer will be option B. Means this semantic rule is associated with the production at the parent of N. Okay, is this clear? Please tell me. The answer is option B. Did you understand this? This explanation, did you clearly understand? Is it crystal clear? Very simple. Remember, the question is saying that inherited attribute of non-terminal B is defined by a semantic rule. There is a semantic rule in which we are defining inherited attribute of non-terminal B. Then you can easily see in this semantic rule, if you are defining inherited attribute of non-terminal B, then definitely this B is on the RHS of the corresponding production. In the corresponding production, this B will definitely be on the RHS. Okay, yes or no? So I can say that this production has head. Let's assume the head is A. Then you can see this production, I can say this is production of A, and this A is the parent of B. So I can say that this inherited attribute of non-terminal B, this will be defined by a semantic rule. This will be defined by a semantic rule which is associated by production at the parent of N. Or I can say production which is the production at the parent of B. Okay, B comma N both are basically same because at the node N we have this non-terminal B. Okay, B comma N both are basically same. Okay, the node name is N and it contains B. Very simple. I hope you understood. Tell me the answer for this question. This question is similar to the previous question. So just take your copy pen so that you don't make any mistake, so that you can be very confident when you give your answer. Okay. So the question is asking a synthesized attribute for a non-terminal A at parse tree node N is defined by a semantic rule associated with which production? Very simple question. The question is saying that at a parse tree node N, there is a parse tree node N. This is the parse tree node N, which contains non-terminal A. We are saying a synthesized attribute. Let's assume that synthesized attribute is that synthesized attribute. Let's call it A, or let's call it T. Okay, let's call it T. So you can see this A dot T. This is your synthesized attribute. Okay, this is the synthesized attribute. Very simple. Now the question is saying synthesized attribute for a non-terminal A at parse tree node N. This is the parse tree node N, and this T is the synthesized attribute. This is defined by a semantic rule. Okay, this is defined by a semantic rule, and this semantic rule is associated with which production? See, I don't know which production. Yes or no? Let's assume this is the production. Okay, for a moment, let's assume this is the production, and with this production, there is a associated semantic rule. Okay, and in this semantic rule, we are defining synthesized attribute of A. Okay, this A dot T we are defining. Is this clear? So notice one thing. The question is saying that defined. The question is saying defined by a semantic rule. So that semantic rule, let's assume this is that semantic rule. Okay, and this semantic rule is associated with this production. So in this semantic rule, we are defining synthesized attribute of A. This A dot T, this is the synthesized attribute. So you can see this T, this is the synthesized attribute of A. Tell me one thing. Corresponding to this production, this semantic rule we have written, in this semantic rule, if I define a synthesized attribute of A, then this A must be on the LHS of the production or on the RHS of the production. Tell me. This A must be on the LHS of the production. Yes or no? If you are defining synthesized attribute in this semantic rule, corresponding to this production, in this semantic rule, if you are defining synthesized attribute of A, then this A must be on the LHS. Yes or no? This A must be on the LHS. Do you agree with me? So this A basically is on the LHS, means this itself is the head. Okay, you are defining synthesized attribute of A, and this A is this A itself is the head of the production. So this production, this is basically A's production. Yes or no? This is basically A's production because this A is the head. So this is basically A's production. So overall, I can say that this semantic rule is associated with production of A itself. Yes or no? Production of A itself. So the answer will be option A, means the production at N itself. Okay, the node N contains A. Basically both are same. Node N, A, both are basically same. So you can easily see that synthesized attribute of non-terminal A you are defining in a semantic rule. Then in the corresponding production, this A will be the head. So I can say the corresponding production is basically A's production. So I can say that this semantic rule is basically associated with production at A itself, or I can say production at N itself. So the answer will be option A. Is this clear to everyone? This is the explanation. You can read it. I hope you understood. Okay, let me tell you, these two questions are basically taken from Ullman book. If you read this paragraph, then these two questions we have answered. Okay, is this clear? You can read this paragraph already. The previous two questions actually are from this paragraph. You can read this, that this was our first question, if you remember. Inherited attribute for a non-terminal B at a parse tree node N is defined by a semantic rule associated with the production at the parent of n. This was our question number 1. We have already seen this. And this was our question number 2, that a synthesized attribute for a non-terminal A at a pass tree node n is defined by a semantic rule associated with production at n itself. This was our question number 2. This was our question number 1. So finally, this paragraph from Ullman book, this paragraph is from Ullman book, and from this paragraph I have created 2 questions, and those 2 questions we have seen. Tell me, the previous 2 questions, did you understand? Are you confident? Like, can you give your answer confidently that this is the answer and this is the logic, this is the reason? Okay, I hope you understood. Let's see the next question. Tell me the answer for this question. If a non-terminal A does not appear on the right hand side of any production rule, then what can we say? Can I say A has no synthesized attribute? Can I say A has no inherited attribute? Think about it. Before giving your answer, think about it, and then you give your answer with confidence. The question is saying non-terminal A does not appear on the right hand side of any production rule. Then what can we say? Can I say that A has no synthesized attribute? Can I say A has no inherited attribute? Tell me, when A can have inherited attribute, just tell me a simple point. When can I say A has inherited attribute? When does A have inherited attribute? When does A have an inherited attribute T? Tell me. Let's assume A has inherited attribute T. Let's assume, for a moment, let's assume that A has inherited attribute T. Okay. Then in that case, if A has inherited attribute T, then in some semantic rule, you are defining that attribute, yes or no? Notice, when can I say that A has inherited attribute T? For a moment, let's assume A has inherited attribute T. Then, in some semantic rule, you are defining this inherited attribute, yes or no? This is the semantic rule. Okay, this is the semantic rule. So in this semantic rule, you are defining this inherited attribute of A. Now remember, in this semantic rule, you are defining inherited attribute of A. So in the corresponding production, this A will appear on the LHS of the production or on the RHS of the production. This A will appear on the RHS of the production, yes or no? Do you agree with me? But the question is saying that, the question is saying non-terminal A, the question is saying that A does not appear on the right hand side of any production. A cannot appear on the right side of any production. If A cannot appear on the right side of any production, then A cannot have inherited attribute. Do you agree with me? If A has at least one inherited attribute, then A must appear on the right side of at least one production. Do you agree with me? So finally, I can say the answer will be option B, that A has no inherited attribute. Did you understand this? Let me know. Is it clear? Is it crystal clear that if a non-terminal A does not appear on the right hand side of any production rule, then we can say that A has no inherited attribute. Okay, this is the explanation. Very simple. But remember, A may or may not have synthesized attribute. Okay, because the question is saying that A does not appear on the right hand side of the production rule, but A can appear on the left hand side of the production rule. Do you agree with me? So if A is appearing on the left hand side of a production rule, A is appearing on left hand side of a production rule. Now, corresponding to this production rule, if I write a semantic rule, corresponding to this production, if I write a semantic rule where I define A dot T, or where I define, let's assume, A dot X, okay, then here you can see that this X will be synthesized attribute of A. Okay, yes or no? Now you can see this X is synthesized attribute of A. Okay, so remember the answer will be option B, that A has no inherited attribute. Okay, very simple. Now the next topic, which is very important topic, that is S attributed SDD, L attributed SDD. Basically, all the SDDs, all the syntax directed definitions, these you can classify into some categories. Okay, and one of the categories S attributed SDD, and this is a subset of L attributed SDD. And there are some SDD which are neither L attributed nor S attributed. Okay, so remember the SDD. Let me tell you. Okay, let me write it here. The SDD, the SDDs that you have. Okay, these SDDs I can classify into categories. One category is S attributed SDD. Another is L attributed SDD. Actually, every S attributed SDD is L attributed SDD also. Okay, so let me make a Venn diagram here. I think that will be a better diagram. So SDDs, if you see, let's assume that this is all SDDs. Okay, these are all SDDs. These are all the syntax directed definitions, and there is a special class of SDD which is called S attributed definitions, or I can say which are called S attributed SDD. Okay, and every S attributed SDD, that is a L attributed SDD. So basically, every S attributed SDD is L attributed SDD. Okay, and there are some SDD which are not L attributed, neither L attributed nor S attributed. Okay, I hope you understood this. Now we need to see the definition of S attributed SDD. We need to see the definition of L attributed SDD. Okay, so this is our topic: S attributed definitions, L attributed definitions, or I can say S attributed SDD, L attributed SDD. Okay, so one by one, let's see the definition. First, we will see the definition of S attributed SDD. This definition is very simple. Those SDD which only have synthesized attributes, those SDD which only have synthesized attributes, these are called S attributed SDD. Actually, the name itself is telling you S means synthesized. Synthesized attributed SDD. You can read like this: S attributed SDD means synthesized attributes SDD, means SDD in which all the attributes are synthesized attributes. There is no inherited attribute. Those SDD are called S attributed SDD. Very simple. Okay. So I hope you understood this definition. So the definition of S attributed SDD. S attributed SDD, or you can say S attributed definition. So you can see an SDD is S attributed if every attribute is synthesized. S means synthesized. So you can read like this, that synthesized attributed SDD. So an SDD is S attributed if every attribute is synthesized. Means there is no inherited attribute. Okay, so you can read this, that an SDD that involves only synthesized attributes is called S attributed SDD. Okay, it is called S attributed definition. In an S attributed SDD, each semantic rule computes an attribute for the non-terminal at the head of the production. Yes, see, read this statement. In S attributed SDD, all the attributes are synthesized. If all the attributes are synthesized, then if you see any semantic rule for any production, let's assume this is a production. Okay, and for this production, a semantic rule I am writing. This is the semantic rule. Okay, this is the semantic rule. A simple point you tell me, if we have S attributed SDD, if we have S attributed definition, then we know that every attribute is synthesized. If every attribute is synthesized, then tell me, in this semantic rule, which attribute will you compute, which attribute will you define? If every attribute is synthesized, then you can see in this semantic rule, if I define this attribute, let's assume this a dot t I am defining. Okay, You can see in this semantic rule, this a dot t I am defining. Then because this a dot t is a synthesized attribute, because we have s attributed SDD, so every attribute is synthesized. So this a dot t is also synthesized. So you can see if this a dot t is synthesized, then definitely this a must appear on the LHS. Yes or no? So you can see that a must appear on the LHS. This is what this statement is saying. You can see this statement is saying that in an s attributed SDD, each semantic rule computes an attribute for the non-terminal at the head of the production. Okay, in this production, this is the head of the production, and this is the body of the production. Okay, this is what this statement is saying. Okay, so that's it. I hope you understood. This is the definition of S attributed SDD. Now we need to see the definition of L attributed SDD. So let's see. Let's understand the definition of L attributed SDD. Remember, L attributed SDD, this does not mean that all the attributes are inherited, because notice in the previous definition, in the S attributed definition, you are using S for synthesized. S for synthesized. Notice. See, in this definition, in S attributed definition, we are using the word S. S stands for synthesized. So I can say like this, that an SDD is S attributed SDD if every attribute is synthesized. Okay, every attribute is synthesized. But notice L attributed SDD. This is not I attributed SDD. Okay, we don't have I attributed SDD. Is this clear? We don't have this category, that I attributed SDD. I attributed SDD means all the attributes are inherited. But we don't have this category. We have this category, L attributed SDD. L attributed SDD. So remember this L, what it means. Here you can see S means synthesized. But what this L means? Does L mean inherited? No, L does not mean inherited. L means left to right or top down. L means left to right. Okay, L means left to right. But also we allow in this L attributed SDD, we also allow top down. Also we allowed synthesized. Okay, so we will see the definition. In L attributed SDD, L means left to right. Okay, so let's see the definition. You will become expert, don't worry. So let's see this definition. You can see L attributed SDD, or I can say L attributed definition. Which SDD is called L attributed? So L stands for left to right. L stands for left to right. Let me tell you the definition now. You can see this is the definition. Read this carefully. Basically, in L attributed SDD, three type of attributes are allowed. Okay, three type of attributes are allowed. So let me tell you, synthesized attributes are allowed, no problem. In L attributed SDD, synthesized attributes are allowed. Okay, so that is the reason you can see that every S attributed SDD is also L attributed SDD, because in L attributed SDD, synthesized attributes are allowed. So if you have all the synthesized attributes, then also this is L attributed also, this is S attributed also. So every S attributed SDD is L attributed SDD. Okay, so you can see what I'm saying here, that in L attributed SDD, synthesized attributes are allowed. What else is allowed? All the synthesized attributes are allowed. Now, in the inherited attributes, which attributes are allowed? In the inherited attributes, there is a condition. The condition is that inherited attributes are allowed, but the dependency should never be from right to left. The dependency should never be from right to left, means from the right sibling, you cannot take data. Okay, that is the reason. Remember, L means left to right. From the left sibling, you can take data. You can depend on left sibling, but you cannot depend on right sibling. Is this clear? You can depend on parent also. You can depend on left sibling also, but you cannot depend on right sibling. You can depend on yourself also. Is this point clear? Very simple. In L attributed SDD, there are three type of attributes are allowed. All the synthesized attributes are allowed. Okay, that is Very simple. All the synthesized attributes are allowed. Inherited attribute. When you say inherited attribute, then there is a condition that those inherited attributes are allowed which do not take data from the right sibling. You cannot have dependency from right sibling. You can take data from the left sibling, you can take data from the parent, you can take data from yourself, means you can depend on yourself, you can depend on left siblings, okay, all the left siblings, you can depend on left siblings, you can depend on parent, but you cannot depend on right siblings. This is called L attributed SDD. There is one more thing, that when you are depending on yourself, like let's assume you are using some of your attribute to compute some of your attribute, okay, like let's assume that one of my attribute I'm using to compute another attribute of mine, okay. Now in this situation, remember, the cycle should not create, it should not happen that to compute this attribute of me I'm using this attribute of me, and to compute this attribute of me I'm using this attribute of me. Like this type of cycle should not create. Okay, is this clear? I hope you understood. So that is the reason I am saying understand this L attributed definition very carefully. Definition is actually very simple. Step by step I am telling you that all the synthesized attributes are allowed. There is no problem with that. Second thing, which inherited attributes are allowed? Those inherited attributes are allowed which do not depend on any right sibling. You can depend on left siblings, you can depend on parent, you can depend on yourself, but you cannot depend on right siblings. And when you depend on yourself, means to calculate one of your attribute, you are using another of your attribute. If you are doing this, then remember, cycle should not create. It should not happen that this attribute of yours is depending on this attribute of yours, and this attribute of yours is depending on this attribute of yours. This should not happen. Cycle should not create. Okay, is this clear? So that's it. This is the definition. I hope you understood. Okay, so let's see this. In L attributed SDD, each attribute must either be synthesized. Okay, synthesized attributes are allowed. Very good, no problem. Or inherited, but there is a condition. But there is a condition that those inherited attributes are allowed where dependency is never from right to left, means you are never dependent on right sibling. Okay, you are never dependent on right sibling. To compute your attribute, you are never using attributes of right siblings. Okay, you can use attributes of left siblings, that's fine. And remember, there should be no cyclic dependency between attributes of itself, between your own attributes. If you have, let's assume, two or more attributes, then between your own attributes there should be no cyclic dependency. This cycle type dependency should not be there. Okay, very simple. So you can read this, that for each attribute of a non-terminal x, okay, for each attribute a, for each attribute a of a non-terminal x, following are allowed. Okay, means if this a is a attribute of x, this a is attribute of x, then which type of attributes are basically allowed? This x dot a can be synthesized, there is no problem. Okay, you can see x dot a, if that is inherited, then remember, it should not depend on right siblings, it should not depend on siblings to its right. Okay, and you can see no cyclic dependency should be there between attributes of x. Between attributes of x means between the attributes of itself, there should be no cyclic dependency. Okay, is this clear to everyone? Let me know. This is very easy definition. I hope you understood. Okay, just you need to take care that those inherited attributes are not allowed in L attributed definition where you are depending on any of your right sibling. You cannot depend on your right sibling. Okay, that's the only point. Also, between your own attributes, there should be no cyclic dependency. It should not happen that this attribute of your is depending on this attribute of your, this attribute of your is depending on this attribute of your, this attribute of your is depending on again this attribute of your. Okay, this type of cyclic dependency should not be there. That's it. Everything else is fine, everything else is allowed. Okay, now let's see two questions. Tell me the answer for this question. Tell me what is the answer for this question. In L attributed SDD, L attributed SDD, you have, suppose that there is a production A going to x1 to xn, this is a production, and there is an inherited attribute xi dot a. Okay, this xi dot a, this is an inherited attribute computed by a rule associated with this production. Okay, corresponding to this production, there is a semantic rule which is computing inherited attribute xi dot a. Can xi dot a depend on an attribute of xi plus 1? The answer is no. Okay, yes or no? Because this xi plus 1, or I can say xi plus 2, these are the right siblings of xi. If you notice, a going to x1, x2, and so on, xi minus 1, xi, xi plus 1, xi plus 2, xi plus 3, and so on, xn. So notice one thing, that for this xi, this is your xi. For this xi, if you are computing inherited attribute a, okay, for this xi, if you are computing inherited attribute a, then you can see these are the right siblings of xi. Yes or no? These are the right siblings of xi. So remember, you this xi dot a, this cannot depend on any attribute of any of these right siblings. Okay, is this clear? So these are the right siblings of xi. So overall, I can say that this xi dot a, remember this xi dot a, this you can write in terms of what? Tell me, this you can write in terms of what? This xi dot a, this you can write in terms of, in terms of attributes of a, that is fine. Okay, you can write in terms of attributes of a. Okay, you can write in terms of attributes of left siblings, yes or no? Attributes of left siblings. Also, you can write in terms of constants. Okay, that is fine. Constants are fine. Okay, also remember, you can write in terms of your own attributes. You can write, you can also depend on your own attributes. Okay, xi dot I. Also constants. Okay, is this clear? But remember, you cannot depend on attributes of right siblings. Okay, is this clear to everyone? Tell me. Very simple question. Okay. One student is asking, do we have LR attributed SDD? No. There are only two famous or two popular classes of SDD. One is S attributed SDD, another is L attributed SDD, and the remaining SDD, these are, I can say, these are not L attributed. Okay. Actually, these two classes are famous. Why these two classes are famous? That I will tell you by the end of this lecture. Okay. Is this clear? And many questions have come based on S attributed SDD, L attributed SDD. So these definitions are very important. S attributed SDD definition is very simple. An SDD which has only synthesized attributes, there is no inherited attribute, that is called S attributed SDD. But you can see the definition of L attributed SDD. It is little bit complicated. You have to understand that in L attributed SDD, which type of attributes are allowed? Synthesized attributes are allowed. Inherited attributes are allowed, but there is a condition that you cannot depend on any of your right sibling. You can depend on your left siblings, you can depend on your parent, you can depend on yourself. When you depend on yourself, then between your own attributes, there should be no cyclic dependency. Okay, this is the definition. Now, very important question I am going to ask you. And in this particular question that I will ask you now, in this particular point, a lot of students have misconception. Okay, and one day they will lose marks in the gate exam because of this small misconception. Okay, so very important question I'm going to ask you now. Tell me the answer. Okay, this is the previous question we have already seen. Tell me the answer for this interesting question. Very interesting question. You will love the answer. Okay, when I explain the answer, you will love it. Okay, see this. In L attributed SDD, suppose that there is a production A going to x1 to xn, and that there is a inherited attribute xi dot A computed by a semantic rule associated with this production. Corresponding to this production, there is a semantic rule which is computing the inherited attribute xi dot A. Can xi dot A depend on a synthesized attribute of parent? So far, what I told you? So far, what I told you? I told you that you can depend on your left siblings, you can depend on your parent, but I'm asking, can you depend on synthesized attribute of your parent? Interesting question. Okay, let me give you the answer. You cannot depend on synthesized attribute of your parent. You can depend on inherited attribute of your parent, but you cannot depend on synthesized attribute of your parent. Do you know why? What is the reason? See the explanation. Okay, just understand the logic. The logic is beautiful. Notice one thing. Let's assume that xi dot a depends on synthesized attribute of parent. Okay, for a moment, let's assume. Okay, so you can see, first of all, you can notice here the question is saying that this is your production. See what is given to you. It is given to you that this is the production x1, x2, and so on, xn. Okay. For simplicity, let me write it a going to, let's assume b c d. Okay, let's write like this just for example. So this is your production. Okay, now corresponding to this production, let's assume a semantic rule I am writing, and in this semantic rule, let's assume inherited attribute of c I am defining. Okay, so inherited attribute of c I am defining c dot t. This is inherited attribute of c, this I am defining. Okay, this I am defining. Now tell me a very simple point. Can this c dot t depend on synthesized attribute of parent? This is what we are asking, right? Now, for a minute, for a moment, assume, for a moment, or I can say for contradiction, assume, for a moment, assume that c dot t depends on a dot s, where a dot s is synthesized attribute of s. Okay, this is a synthesized, s is synthesized attribute of a. Okay, so this is synthesized attribute. This is synthesized attribute of A. Is this clear? A dot S, this is the synthesized attribute. Basically, S is the synthesized attribute of A. Okay, this is the synthesized attribute. Okay, now you can see for a moment, let's assume that C dot T depends on synthesized attribute. Now remember, because this A dot S, this is synthesized attribute, right? For a moment, we are assuming that C dot T depends on synthesized attribute of parent. So this A dot S, this is synthesized attribute. If this A dot S is synthesized attribute, then tell me, is it possible that this A dot S, because this is a synthesized attribute, okay, because this A dot S is synthesized attribute, so is it possible that this A dot S can depend on attribute of D? Tell me, is it possible? A dot S is synthesized attribute. This S, this is synthesized attribute of A. So tell me, this A dot S, can I write in terms of D? Can I write in terms of D? Tell me. Like, can I write like this in terms of D? Let me know. Yes, this is possible. Yes or no? Do you agree this is possible? Let me know. Is this possible or not? Yes, this is possible because A dot S, this is the synthesized attribute of A. If this is the if this S is the synthesized attribute of A, then you can see that this A dot S I can write in terms of D dot X. So now did you notice something interesting, that this A dot S, this depends on D dot X, and C dot T, that depends on A dot S. So did you notice that this C dot T indirectly depends on right sibling or not? Indirectly depends on right sibling or not? In the L attributed SDD, can you depend on right sibling? Tell me. You can see this D is the right sibling. This is the right sibling of, this D is the right sibling of C. Yes or no? Okay. So did you understand this point? I am saying that if this C dot T, this is an inherited attribute of C, if this depends on synthesized attribute of A, then this synthesized attribute of A can depend on its child. Yes or no? Synthesized attribute can depend on children. Okay. Are you getting my point? This synthesized attribute can depend on children. So synthesized attribute can depend on X, can depend on D. The synthesized attribute can depend on D. So you can see this synthesized attribute depends on D, and this C depends on the synthesized attribute of parent. So indirectly you can see that this C is depending on right sibling. Okay. So I hope you understood this point. So you can see this is not allowed in, this is not allowed in L attributed SDD. Okay, is this point clear? Now I will give you the final definition of L attributed SDD. But did you understand this point? Tell me. Now I will give you the final point. But did you understand this point? Let me know. So remember, the answer will be what for this question? Can x dot can xi dot a depend on synthesized attribute of parent? The answer is no. Okay, and what is the reason? Let me tell you. The reason. Let me make a diagram. You can see the reason is like this. You can see that this a, x1, x2, okay, this is xi, this is xn. So you can see that this is the situation. Okay, this is the production. Now you can see if xi dot a, if xi dot a, if that depends on synthesized attribute of a. Okay, let's assume there is a synthesized attribute of a. Let's assume this. Assume S is synthesized attribute of A. Okay. So S is synthesized attribute of A. Okay. And assume that this xi dot A, this depends on synthesized attribute of parent. Then you can see what can happen. See, it can happen that this depends on this. Okay, sorry, I can say that to calculate this, let's assume that you need this. Okay, you can see that this depends on this, means to calculate this you need this. Okay, so you can see it is like this. And because this is synthesized attribute of A, so synthesized attribute can depend on its children. Yes or no? We already know synthesized attribute can depend on children. So synthesized attribute of A can depend on children, can depend on children, children of A. Okay. So you can see that what can happen. Maybe this synthesized attribute depends on children of, let's assume maybe this depends on this. Okay, means to calculate this synthesized attribute, you need, let's assume this. Okay. So did you notice that what is happening indirectly? This is happening. Indirectly, this is happening. Indirectly, this is happening that this is happening. Okay, indirectly, this is what is happening. Okay. So you can see indirectly this attribute depends on right sibling. Okay, is this clear? So this is a contradiction. Ultimately, this is a contradiction. Or I can say this is contradiction. Okay, I hope you understood this. Very simple. Now let me give you the final definition of L attributed SDD. Okay, so let's see the final definition of L attributed SDD. Let's see. This is the final definition of L attributed SDD. In L attributed SDD, if you have any attribute x dot a, means a is attribute of non-terminal x. So if you have any attributed, if you have any attribute x dot a, then what are allowed? X dot a can be synthesized. Yes, that is perfectly fine. All the synthesized attributes are allowed in L attributed SDD. If x dot a is inherited attribute, then what are the conditions? X dot a can be inherited, but it should not depend on siblings to its right. Okay. So notice one more thing. Because x dot a, if that is inherited, then it cannot depend on siblings to its right. Then automatically I can say that, indirectly I can also say that this should not depend on synthesized attribute of parent. Means it can depend on inherited attribute of parent, but it cannot depend on synthesized attributes of parent. Okay. The next is no cyclic dependency should be there between attributes of x. Okay. Basically, let me write this fourth point explicitly, that if this x dot a is inherited, then it should not depend on synthesized attribute of parent. Okay. You can see if x dot a is inherited, then it must not depend, it must not depend on synthesized attribute of parent. Synthesized attribute of parent. Okay. Now let me write it mathematically, because that is more easy to understand, more easy to remember. Okay. So let me write it mathematically. Basically, what things are allowed, what things are not allowed. So you can see, let me write mathematically what are allowed things. What is allowed for x dot a? Okay. What is allowed for x dot a? The first thing that is allowed for x dot a, that is it can be synthesized. Okay. X dot a is synthesized. That is allowed for x dot a. Synthesized allowed. Okay. Means x dot a is synthesized, that is allowed. Okay. Now if x dot a is inherited, if x dot a is inherited, then what are the conditions? If x dot a is inherited, then what should happen? Then you can see, then what should happen? Let me assume that you have this production. Okay, for a moment, let me take a production. Let me take a production, that is a going to let's assume x1, x2, x, and then here you have, let's assume x4, x5, like that. Okay, so let's assume this is the production. Okay, now if x dot a is inherited, then this x dot a can depend on what? Okay, so let's see. Then you can see this x dot a, this can depend on inherited attribute of parent. Okay, remember, this can depend on inherited attribute of parent. Okay, and this can depend on synthesized or inherited any attribute of left siblings. Okay, this can depend on any attribute, synthesized or inherited any attribute of left siblings. Okay, also remember, it can depend on any attribute of itself also. Okay, it can depend on any attribute of itself also. Is this clear? So here let me write this thing, that this must be inherited. Okay, this is inherited, this must be inherited, means inherited attribute of parent. Okay, but remember, it can depend on any attribute, synthesized or inherited, of its left sibling, also its own. So these can be synthesized These can be synthesized or inherited. These can be synthesized or inherited. These are perfectly fine. But remember, for the parent, it must be inherited. Okay, means you can depend on inherited attribute of parent. You cannot depend on synthesized attribute of parent. Okay, is this clear? So if you are depending on any attribute of parent, it must be inherited attribute. Okay, but remember, you can depend on any attribute of left siblings. You can depend on any attribute of yourself. Okay, is this clear? Let me know. There is one more condition, that among its own attributes there should be no cycle. Okay, means no cycle between attributes of xa. Okay, and you can write it here, and no cycle between attributes of this x itself. Okay, means basically it should not happen that, let's assume that x dot a, to compute x dot a, let's assume you need to compute x dot a, let's assume you need x dot b, and let's assume to compute x dot b you need x dot c, and let's assume to compute x dot c you need x dot a. Okay, this is cyclic dependency. This is cyclic dependency between attributes of x. Okay, this type of cyclic dependency, this is not allowed in L attributed SDD. This is not allowed in L attributed SDD. Okay, that's it. I hope you understood this point. Okay, now you can see this is the definition. This definition I have explained to you. In S attributed SDD, each attribute must be either synthesized. Synthesized attributes are allowed. Basically, in L attributed SDD, which type of attributes are allowed? Synthesized attributes are allowed. There is no problem. Inherited attributes are allowed, but there is a condition. What is the condition? If you have this production A going to x1, x2, xn, if you have this production, then remember, inherited attribute are allowed, but limited. There basically limited type of inherited attributes are allowed. Okay, what are the conditions? The conditions are like this. If there is an inherited attribute xi dot a, this is computed by a semantic rule associated with this production, then remember, then this semantic rule can use inherited attribute of parent. Okay, did you notice that this xi dot a, this can depend on inherited attributes of parent? It cannot depend on synthesized attributes of parent. It can depend on inherited attributes of parent. Another thing, what the next thing? It can depend on inherited or synthesized attributes of left siblings. Okay, it can depend on inherited or synthesized attributes of left siblings. Also remember, it can depend on inherited or synthesized attributes of itself. It can depend on inherited or synthesized attributes of itself. But there is a condition. What is the condition? There should be no cyclic dependency between the attributes of itself. Okay, between the attributes of itself, there should be no cyclic dependency. Okay, so that's it. I hope you understood. And this is the note. Every S attributed SDD is also L attributed SDD, because in L attributed SDD, synthesized attributes are allowed. In S attributed SDD, all the attributes must be synthesized. Okay. Now we are going to do a lot of practice, and we will solve all the gate PYQs also. So let's consider this question. Tell me the answer. An SDD contains the following production and the rule. These are the rules associated with this production. So an SDD contains the following productions and the rules. Can this SDD be L attributed SDD? Very simple question I am asking. This SDD, which contains this production and these semantic rules associated with this production, then this SDD, can it be L attributed SDD? You can notice, look at this semantic rule. In this semantic rule, you can see these are the semantic rules associated with this production. You can see in this semantic rule, we are defining as attribute of A. A is LHS. We are defining attribute of LHS. So this is synthesized attribute. Yes or no? This is synthesized attribute, and synthesized attributes are allowed. So this is not a problem. This is perfectly fine. This rule has no problem. I can say this rule is allowed in L attributed SDD. Okay, is this clear? I can say this is L attributed rule. I can say that this is allowed in L attributed SDD. This is allowed in L attributed SDD. Or I can say that basically I can say that this is a L attributed rule. Okay, this is what I can say. I can say this is L attributed rule. Okay, what I can say this is a L attributed rule. Okay, because this rule is perfectly fine. This is L attributed rule. Why this rule is perfectly fine? Because remember, corresponding to this production, these are the semantic rules. And you can see in this semantic rule, we are defining attribute of LHS. This A is on the LHS. We are defining attribute of LHS. So you can see this is basically synthesized attribute. And you can see synthesized attributes are allowed in L attributed SDD. There is no problem. Okay. What about this? What about this semantic rule? In this semantic rule, first of all, we are defining attribute of RHS non-terminal. You can see we are defining attribute I of B, and this B is on the RHS. So one thing you can say that this is basically inherited attribute of B. Yes or no? Yes or no? This is inherited attribute of B. Attribute of B. This is inherited attribute of B. Remember, inherited attributes are allowed in L attributed definition, but there is a condition. What is the condition? The condition is that you cannot depend on attributes of your right siblings. You cannot depend on synthesized attributes of your parent. Okay, is this clear? These things are the restrictions. Okay, so you can easily see here that in this semantic rule, we are defining attribute of B. B is on the RHS. So in this semantic rule, we are defining attribute of RHS. So definitely this is inherited attribute of B. Now this type of inherited attribute is allowed or not in the L attributed SDD. So for that you check two things. You check actually total three things you need to check. First, you check this inherited attribute, does it depend on attribute of any right sibling? You also check if you do not depend on attributes of the right sibling, then you check, are you depending on synthesized attribute of parent? If you are not depending on synthesized attribute of parent, then what you check? Then you check among your own attributes, is there any cyclic dependency? These three things you need to check. Okay, so let's see here. You can see this is inherited attribute of B, and you can see that this inherited attribute actually depends on its right sibling. Okay, yes or no? This is the right sibling attribute. This is the attribute of right sibling. Okay, yes or no? This is the attribute of right sibling. Attribute of right sibling. So you are depending on attribute of right sibling. That is not allowed. Do you agree with me? One more thing. This is also a violation. This is synthesized attribute of A. This we have already seen that S is synthesized attribute of A. From this rule, you can see that S is synthesized attribute of A. S is synthesized attribute of A. S is synthesized attribute of A. Okay. And notice one thing, that you are depending on synthesized attribute of parent. Yes or no? This B dot I, this is depending on attribute of right sibling also. This is depending on synthesized attribute of parent also. So these are the two violations. One violation is enough, but actually we have two violations. So you can see this is actually synthesized attribute of parent. Okay, so both are the violations. Is this clear? I can say this is also a violation, and you can say this is also a violation. Both are the violation. Okay, so finally I can say, can this SDD be L attributed? The answer is no. Okay, is this clear? Let me know. So you can see this is the explanation. You can easily see. Let's solve this question. Tell me the answer. An SDD contains the following production and the rules. This is a production and these are the semantic rules associated with this production. Can this SDD be L attributed? The question is saying that the non-terminals A comma B we have. These are the non-terminals A comma B. And they have synthesized and inherited attributes A dot S and B dot I respectively. Means this A dot S, A has synthesized attribute S, B has inherited attribute I. Okay. So now the question is asking, can this SDD be L attributed SDD? So let's check. You can see A dot S is synthesized attribute of A. B dot I is inherited attribute of B. This is the production. These are the associated semantic rules. Okay. Let's check this semantic rule. In this semantic rule, we are defining attribute of LHS. So this is synthesized attribute. Synthesized attribute are allowed. No problem. Yes or no? Okay, because here you can see that, here you can notice that in this semantic rule, we are defining attribute of A. A is on the LHS. We are defining attribute of LHS. So this is synthesized attribute of LHS, means this S is synthesized attribute of A. Yes or no? So I can say A dot S is synthesized. A dot S is synthesized. So synthesized attributes are perfectly fine. Synthesized attributes are allowed in L attributed SDD. Okay, yes or no? So this is perfectly fine. Now, let's see the next rule. Next semantic rule. In the next semantic rule, you can see we are defining attribute of B. B is on the RHS. We are defining attribute of RHS. So this is definitely inherited attribute of B. Yes or no? This is inherited attribute of B. Okay, because you can see in this semantic rule, we are defining attribute of B. B is on the RHS. We are defining attribute of RHS. So this is an inherited attribute of B. This I is an inherited attribute of B. And you can see this depends on what? This depends on synthesized attribute of parent. Yes or no? A dot S, that is synthesized attribute. A dot S is synthesized attribute of A. So you can see that this inherited attribute of B, this depends on synthesized attribute of parent. Is it allowed in L attributed SDD? No, it is not allowed. Yes or no? So can this SDD be L attributed? The answer again is no. Because remember, you can see this B dot I, which is an inherited attribute, it depends on synthesized attribute of parent. So this is the violation. Yes or no? You can see here you have the violation. What is the violation? Tell me. The violation is very simple, because this B dot I depends on synthesized attribute of parent. Yes or no? Okay. This B dot I, to calculate this B dot I, first you need to calculate the synthesized attribute of parent. Basically, this B dot I depends on synthesized attribute of parent. Okay. Synthesized attribute of parent. This is synthesized attribute of A. A is the parent of B. Okay, so very easily you can see that this is a violation. I hope you understood. So this SDD is not L attributed SDD. So the answer is no. Okay, I hope you understood. Let's solve this question. This SDD is given to us and the question is asking, is this SDD L attributed SDD? Some information is given in the question. Each of the non-terminals T, F have synthesized attribute val, 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 and the terminal digit has synthesized attribute lex val, lexical value. The non-terminal T dash has two attributes, an inherited attribute INH, a synthesized attribute SYN. Okay, so you can see these are the non-terminals T, T dash, F. And the question is saying that T, F, they have synthesized attribute val. Val means value. This digit, this is a terminal. This terminal digit has synthesized attribute lex val, lex value, lexical value. And this T dash, this non-terminal T dash has inherited attribute INH and synthesized attribute SYN. Now the question is asking, is this SDD L attributed SDD? Let's check. In L attributed SDD, synthesized attributes are allowed. Inherited attributes are allowed, but there is a condition that the inherited attribute cannot depend on its right siblings. It cannot depend on synthesized attributes of its parent. Also, among its own attributes, there should be no cyclic dependency. Okay, so here let's check all the semantic rules for this production. These are the two semantic rules. So you can see in this semantic rule, you can notice we are defining attribute of T dash. T dash is on the right side. So you can see that this is inherited attribute of T dash. Also, it is given in the question that this INH, this is inherited attribute of this T dash. Okay. So you can see for this production, these are the semantic rules associated. In this semantic rule, let's check. In this semantic rule, we are defining this attribute INH of T dash. T dash is on the RHS. So we are defining attribute of RHS. So I can say this is inherited attribute of T dash. Okay. And this inherited attribute of T dash, you can notice this depends on left sibling attribute. Yes or no? And I told you that in L attributed SDD, you can depend on any attribute of your LHS sibling, any attribute of your left siblings. Okay. Remember, in the L attributed definition, you can depend on any attribute, any inherited attribute can depend on any attribute synthesized or inherited, any attribute of its left siblings. Okay, so very simple. Here you can see that this inherited attribute of T dash, it depends on val attribute of its left sibling. So yes, this rule is perfectly fine. This rule is allowed in the L attributed SDD. Yes or no? This rule is, I can say this rule is L attributed rule. I can say, okay, I can say this rule is L attributed rule. This is what I can say. I can say this rule is L attributed rule. Or I can say that this rule is allowed in L attributed SDD. Very simple. Now let's see the next rule. Here you can see in this next semantic rule, we are defining attribute of T. T is on the LHS. We are defining attribute of LHS. So this is synthesized attribute. Yes or no? So synthesized attributes are allowed in L attributed SDD. So this is also perfectly fine. Okay, is this clear? So you can see, because in this semantic rule, we are defining attribute of LHS. So this is synthesized attribute, and synthesized attributes are allowed in the L attributed definition. Okay, now let's see. For this production, these are the semantic rules associated. Let's check these semantic rules one by one. Let's check this semantic rule. In this semantic rule, this T1 dash, we are defining attribute of T1 dash. You can see T1 dash is on the RHS. So you can see we are defining attribute of RHS. So this is a inherited attribute of T1 dash. Remember, T1 dash is same as T dash. Okay, they are basically same variable, different instances. So basically here you are defining inherited attribute of T1 dash. And in this inherited attribute depends on, it depends on the inherited attribute of parent. That is fine. Yes or no? Inherited attribute can depend on inherited attribute of parent. Okay, so you can see that this inherited attribute of T1 dash you are defining, and it depends on inherited attribute of parent. That is perfectly fine. It also depends on synthesized attribute of left sibling. That is also perfectly fine. Yes or no? Inherited attribute in the L attributed definition. In the L attributed definition, remember, the inherited attribute can depend on any attribute of left sibling, synthesized or inherited, any attribute of left sibling. It can depend on inherited attribute of parent. Okay, here you can easily see in this semantic rule. In this semantic rule, you can see that we are defining inherited attribute of T1 dash. It depends on inherited attribute of parent. Also, it depends on synthesized attribute of left sibling. So this is perfectly fine. This rule is also L attributed rule, or I can say this rule is allowed in L attributed definition. Okay, let's see the next semantic rule. Here we are defining attribute of T dash. T dash is LHS. We are defining attribute of LHS. So this is synthesized attribute. Synthesized attributes are allowed in L attributed definition. So this is also allowed. Okay, let's see this production. For this production, this is the semantic rule associated. In this semantic rule, you can see we are defining attribute of t dash. T dash is on the LHS. So we are defining attribute of LHS. Yes or no? We are defining attribute of LHS. So this is a synthesized attribute of LHS. This is synthesized attribute you are defining, and synthesized attributes are allowed in L attributed definition. So this is also allowed. This semantic rule is also allowed. Let's see this production. For this production, these are the semantic rules associated, and in this semantic rule you can see we are defining attribute of f is on the LHS. We are defining attribute of LHS. So this is a synthesized attribute, and remember in L attributed definition, synthesized attributes are allowed. So I can say this rule is also L attributed rule. This rule is also allowed in L attributed definition. So you can see all the rules are allowed in L attributed SDD, or I can say all the rules are L attributed rule. So definitely I can say this SDD is L attributed. Yes or no? This SDD is L attributed. Notice one more thing. This SDD is not S attributed, because S attributed SDD has only synthesized attribute, no inherited attribute. But here actually you have inherited attribute. Yes or no? So you can see this SDD, you can see this SDD is not S attributed. This SDD is not S attributed, but it is L attributed. Okay, yes or no? But it is L attributed. Very simple. Now let's move on. So basically, this was our previous question. You can read this explanation yourself. Okay, we have already seen this. Let's solve this question. This SDD, is it L attributed? Is it S attributed? This is what we need to check. So the question is this SDD L attributed? Is this SDD L attributed? This is the question. Okay, so let's solve it. Let's check all the productions and all the semantic rules. Let's check whether all these semantic rules, these are L attributed rules or not. Basically, these are allowed in L attributed SDD or not. Let's check. Okay, so let's start with this production. For this production, these are the semantic rules associated. Let's check this semantic rule. In this semantic rule, we are defining b.pos, means we are defining pos attribute of b. B is on the LHS. We are defining attribute of LHS in this semantic rule. So we are defining attribute of LHS means this attribute is synthesized attribute. Yes or no? And remember, synthesized attributes are allowed in L attributed SDD. So you can see that this rule is perfectly fine. I can say this rule is L attributed rule. This rule has no problem, because in this rule we are defining synthesized attributes, and synthesized attributes are perfectly fine, are allowed in L attributed SDD. Okay, let's see the next rule. In the next rule, you can see we are defining b.val. B is on the LHS. We are defining val attribute of B. We are defining attribute of LHS. So this is also synthesized attribute. This VAL, this is synthesized attribute of B. And remember, synthesized attributes are allowed in L attributed SDD. So you can see this rule is also perfectly fine. Okay, this semantic rule is also allowed in L attributed SDD. Okay, very simple. Now let's see the next rule. Let's see this rule. You can see in this rule, we are defining d.pow. D is on the RHS. So we are defining attribute of RHS. So this is inherited attribute. This d.pow. For this non-terminal d, pow is inherited attribute. This inherited attribute, you can notice, this depends on what? This depends on right sibling. Yes or no? This b1.pos. b1 is the right sibling of d. So you can see this inherited attribute depends on attribute of right sibling. Okay, so this is not allowed in L attributed SDD. Is this clear? So you can see this rule, this is not L attributed rule. This is not L attributed rule. Okay, because there is at least one rule which is not L attributed. So I can say that this SDD is not L attributed SDD. This is not L attributed SDD. Okay, is this clear? I hope you understood. Notice that here you are defining attribute of RHS. So this is actually inherited attribute of D. Okay, you can notice that this POW is inherited attribute of D. Inherited attribute of D. And remember, because there is at least one inherited attribute in our SDD, so I can say that this SDD is not as attributed SDD. Yes or no? So, not as attributed SDD. Okay, because in as attributed SDD, all the attributes must be synthesized attributes. But here you can see that this semantic rule is defining attribute of D. D is on the RHS. We are defining attribute of RHS. So this attribute is inherited attribute of D. So this POW, this is inherited attribute of D. And if your SDD has at least one inherited attribute, then it is not as attributed SDD. So you can see this SDD, this is not as attributed, this is not L attributed. Okay, is this clear? Now let's check the remaining rules also. The remaining semantic rules, are they allowed in the L attributed SDD or not? Means the remaining semantic rules, are they L attributed rule or not? Okay, so let's check. Is this L attributed rule? You can see this one. Is this L attributed rule? You can see here in this rule, we are defining attribute of B. B is on the LHS. So we are defining attribute of LHS. So this is synthesized attribute, and synthesized attributes are allowed in L attributed. Okay, yes or no? So yes, this is L attributed rule, I can say. What about this rule? In this rule also, we are defining attribute of B. B is on the LHS. We are defining attribute of LHS. So this is synthesized attribute, and synthesized attributes are allowed in L attributed definition. So this is also L attributed rule. Let's check this. Is this L attributed rule? You can see we are defining attribute of D. D is on the RHS. So remember, this is inherited attribute of D. But remember, this inherited attribute of D, you are defining in terms of constant. So this is perfectly fine. Yes or no? Inherited attribute you can define in terms of constant. That is perfectly fine. Okay, but inherited attribute you cannot define. You cannot depend on your right siblings. Yes or no? So remember, this is not L attributed rule, but this is L attributed rule. Okay, let's see the next. This is a synthesized rule. Okay, here you can see this is synthesized attribute because you are defining this attribute of D. D is on the LHS. So this is synthesized attribute of D. Synthesized attributes are allowed in L attributed definition. So this is also L attributed rule. Okay, what about this? Is this L attributed rule? Here you can see that we are defining this attribute of D. D is on the LHS. So we are defining attribute of LHS. So this is synthesized attribute, and synthesized attributes are allowed in L attributed definition. So I can say this is also perfectly fine. Basically, this is the only violation. Okay, is this clear? So remember, these are, if you look at these are L attributed rules. These are L attributed rules. Okay, so I can say that this is the only violation of L attributed rule. Okay, is this clear? I can say this is the only violation of L attributed rule. This is the only violation. The only violation of L attribute. Okay, I hope you understood. So finally, I can say this SDD, this is not L attributed SDD. Okay, very simple. I hope you understood. Let's take this question. This SDD, is this L attributed SDD? See, a lot of practice question I am taking, then I will take all the gate PYQs also. Based on this topic, there are many gate PYQs, those also we will solve. Okay, so tell me about this one. This SDD, is this L attributed SDD or not? So this is the question. This is the question. What are S attributed rule and what are L attributed rule? Okay, so which rules means which rules are allowed in S attributed SDD? Which rules are S attributed? Which rules are allowed in S attributed SDD? Which rules are L attributed? Means which rules are allowed in L attributed SDD? Okay, this is the question. So let's see the answer. Let's check. You can see these are the productions, these are the associated semantic rules. Okay, here with this production, this is the associated semantic rule, and in this semantic rule we are defining attribute of L. L is on the LHS. We are defining attribute of LHS. So this is synthesized attribute. Synthesized attribute is allowed in inherit. Synthesized attribute is allowed in L attributed SDD also, S attributed SDD also. So remember, this is allowed in S attributed SDD also. This is allowed in L attributed SDD also. Okay, is this clear? So remember this tick mark. This is for the first tick mark is for S attributed rule. Okay, so let me tell you here that the first check mark, the first tick, I can say. Okay, so let me do like this. The first tick is for S attributed rule. The first tick is for S attributed rule. Second second tick is for L attributed rule. Okay, so you can see in this rule we are defining synthesized attribute, and synthesized attributes are allowed in both S attributed SDD also L attributed SDD. Okay, so this is perfectly fine. Let's see the next. In this semantic rule associated with this production, you can see we are defining e dot val. E is on the LHS. Again, this is also synthesized attribute which is allowed in both S attributed definition also in L attributed definition. Okay, so this is S attributed rule, also this is L attributed rule. Okay, let's see the next. This semantic rule associated with this production, here we are defining e dot val. This e is on the LHS, so this is also synthesized attribute, and synthesized attributes are allowed in both S attributed and L attributed rules. Okay, very simple. Now let's see the next. Let's see, this production has this semantic rule. In this semantic rule we are defining this val attribute of t is on the LHS, so this is also synthesized attribute. This here also we are defining synthesized attribute, so this is allowed in both S attributed SDD and L attributed SDD. Okay, next you can see for this production we have this semantic rule. In this semantic rule we are defining attribute of t is on the LHS. Here also you can see in this semantic rule we are defining attribute of f is on the LHS. In this semantic rule also we are defining attribute of f is on the LHS. So remember, in these semantic rules we are defining attributes of LHS, so these are synthesized attributes. We are defining synthesized attributes, and remember, defining synthesized attributes is allowed in S attributed definition also, L attributed definition also. So these rules are S attributed rules, also L attributed rules. Okay, so I can say tick mark, tick mark, tick mark, tick mark, tick mark, tick mark. Okay, so finally, what will be your answer? Your answer will be that this SDD is S attributed as well as L attributed. Okay, is this clear? So I can say that this SDD is S attributed and L attributed. Okay, actually every S attributed SDD is also L attributed SDD automatically. Okay, so I can say that this SDD is basically S attributed SDD, automatically it will be L attributed SDD. Okay, very simple. I hope you understood this. Let's consider this question. Is this SDD L attributed? Is this S attributed? Basically, all the rules that are given to you, you just find which rules are S attributed rule, which rules are L attributed rules. Okay, so basically the question is like this, that which rules are S attributed, which rules are S attributed, okay, which rules are L attributed, which rules are S attributed, which rules are L attributed. Okay, so let's quickly see this. Let's see all the rules. This rule is associated with this production. In this rule we are defining attribute v of b. B is on the LHS, so we are defining attribute v of b, attribute of LHS. So this is synthesized attribute we are defining. Okay, notice one thing, that here notice that this means what? This means b dot v. Okay, basically v is the attribute of b. Okay, is this clear? So here basically this is synthesized attribute you are defining, and defining synthesized attribute is allowed in S attributed SDD, also L attributed SDD. So I can say for this rule I will say 2 tick mark I will put. Okay, 2 tick mark. Okay, is this clear? two tick mark for this rule. Let's see for this rule. In this rule, you can see that we are defining attribute v of b. B is on the LHS. So again, we are defining synthesized attribute. Okay, so this is also allowed in both S attributed SDD, also L attributed SDD. Okay, let's see the next. You can see, look at this rule. Okay, notice here we have these rules. This is a rule, this is a separate rule, and this is another rule. Okay, so let's see the first one. Okay, let's see about this rule. So you can see in this rule we are defining attribute v of L. L is on the LHS, so I can say this is basically synthesized attribute. Okay, defining synthesized attribute is allowed in both S comma L attributed SDD. So I can say for this I will say tick mark tick mark. Okay, for this I will say tick mark tick mark. Okay, let's see the next. Look at this rule. In this rule we are defining S attribute of b. B is on the RHS. We are defining, in this rule we are defining attribute of RHS. So this is inherited attribute. Remember, inherited attribute is not allowed in S attributed SDD. So this rule is not S attributed rule. What about L attributed rule? So you can see here that here you can notice that we are defining inherited attribute of b, and this depends on attribute of L. We need to check, is this inherited attribute of parent or is this synthesized attribute of parent? Because remember, in L attributed definition, in L attributed SDD, inherited attribute can depend on inherited attribute of parent. Inherited attribute cannot depend on synthesized attribute of parent. So here you can notice we need to check this S, is this synthesized attribute of L or is this inherited attribute of L? That is what we need to check. This S, is this synthesized attribute of L? Is this inherited attribute of L? How to check it? How to check it? Tell me. See, notice one thing. Here we need to check something. Okay, now here we need to check. We need to check if SL is synthesized or inherited. Synthesized or inherited. Tell me how you will check it. Let me know how you will check it. Whether S is synthesized or inherited attribute, how you will check it. Very easy to check. Okay, what you see? Just see here. Look at this. Okay, for this production, this is the semantic rule. Look at this semantic rule. In this semantic rule, I'm defining attribute S of L. L is on the RHS. Yes or no? In this semantic rule for this production, we are defining attribute S of L. And you can see this L is on the RHS. So from here, one thing you can notice that this SL is inherited. Yes or no? Did you understand this? Tell me. So you can easily see that this SL is inherited. Is inherited. Okay, is this clear? So there is no problem. Remember, this SL, this is inherited. This is inherited. Okay, so inherited attribute of parent. Yes, so inherited attribute of parent, that is perfectly fine. You can depend, inherited attribute can depend on inherited attribute of parent, that is perfectly fine. So this rule is L attributed rule. I hope you understood. Okay, very simple. So this is a beautiful question, because you have to check that this inherited attribute of B, is it depending on synthesized attribute of parent or is it depending on inherited attribute of parent? So actually this SL, this is actually inherited from here, you can find. Okay, so I can say this rule is L attributed rule. This is allowed in L attributed SDD. What about this rule? Here you can see we are defining attribute of L. L is on the LHS. So this rule is actually allowed in S attributed SDD also, L attributed SDD also, because you are defining attribute of LHS. So this is synthesized attribute basically. Okay, and synthesized attribute is allowed in both S attributed SDD also, L attributed SDD. Okay, very simple. Okay, now let's see quickly the remaining. What about this rule? Is this rule allowed in L attributed, S attributed? So let's check here. Here you are defining attribute of L1. L1 is on the LHS. So you are defining attribute of LHS. So this is synthesized attribute. This is allowed in both S attributed, also L attributed SDD. Let's check this rule. In this rule, we are defining attribute of B. B is on the RHS. We are defining attribute of RHS. So this is inherited attribute. This inherited attribute actually depends on SL1. Okay, SL1. So we need to check. We need to check this SL1, is this inherited or is this a synthesized? Okay, did you understand? Notice one thing, that this inherited attribute of B, this is depending on S attribute of L1. Okay, means this depends on attribute of parent. So we need to check that this SL1 means the attribute of parent on which this inherited attribute is depending on, this attribute of parent is synthesized or inherited. This is what we need to check. Yes or no? To check, need to check, need to check if, need to check if S of L1, S of L1 is synthesized or inherited. Okay, this is what we need to check. So how you will check it? Tell me. Just let's see. For example, here you can see SL1 you are defining. Okay, corresponding to this production rule, this semantic rule we have, and you can see here you are defining SL1, S attribute of L1. L1 is on the RHS. So this is inherited attribute. Yes or no? So from here actually you can easily see that SL1 is inherited attribute of L1. Okay, is this clear? So you can see from here you can easily see that, from here you can easily see that SL1 is inherited. Okay, because you can see here you are defining SL1, attribute of L1. L1 is on the RHS. So you are defining attribute of RHS. So I can say that SL1, that is inherited attribute. Okay, so finally I can say that this is also perfectly fine. Yes or no? This is allowed in, I can say this is not the first tick mark, means this is not allowed in, I can say that this is not allowed in S attributed, but this is allowed in L attributed. Okay, is this clear? The first tick mark is for S attributed, the second tick mark is for L attributed. So you can see that this rule is allowed in L attributed SDD. Okay, what about this rule? What about this rule? Here you can see we are defining S attribute of L2. L2 is on the RHS. So this is inherited attribute. Now you can see this inherited attribute, it depends on attribute of parent. And you can see already we have seen that SL1, that is inherited. So I can say inherited attribute can depend on inherited attribute of parent. Yes, that is perfectly fine in L attributed SDD. So you can see this is allowed in L attributed SDD, but this is not allowed in S attributed SDD. Okay, so very simple. What about this one? Here you can see that we are defining attribute of L1. L1 is on the RHS. Sorry, L1 is on the LHS. So this is synthesized attribute. So I can say this is allowed in both S attributed SDD, L attributed SDD. Okay, let's see the next. Let's see this one. Here you can see we are defining attribute of N. N is on the LHS. So this is allowed in S attributed SDD also, L attributed SDD also. Okay, let's see this one. Here you are defining attribute S of L. L is on the RHS. So this is inherited attribute. You are defining inherited attribute. So this is not allowed in S attributed SDD. Means this is not S attributed rule, but this is allowed in L attributed rule. Yes or no? This is inherited attribute, and this you are defining in terms of constant. That is perfectly fine. Okay, let's see the next. Let's see this one. You can see here you are defining attribute V of N. N is on the LHS. So this is synthesized attribute, and this is perfectly fine. This is allowed in both S attributed SDD and L attributed SDD. Okay, let's check this one. Here you can see we are defining attribute S of L1. L1 is on the RHS. So this is inherited attribute. Inherited attribute is not allowed in S attributed SDD, but it is allowed in L attributed SDD. Here you can see that this inherited attribute you are writing in terms of constant. That is perfectly fine. Okay, so like this. Now what about this last one? What about this last one? What about this one? So you can see here you are defining attribute s of L2. L2 is on the RHS, so this is inherited attribute. You are defining inherited attribute, so this is not allowed in S attributed SDD. But is this allowed in L attributed SDD? Let's check. You can see here, this is inherited attribute of L2, and this is depending on another attribute of L2. Remember, this is inherited attribute of L2. This is depending on another attribute of L2. So what you need to check? Tell me. Notice one thing, that this attribute s of L2, this is depending on another attribute of L2. Okay, so what you need to check? In the L attributed SDD, can any inherited attribute depend on attributes of myself? Like, let's zoom. My inherited attribute, can it depend on another attribute of myself? Yes, it is allowed, but there should be no cyclic dependency. Yes or no? You should check. There should be no cyclic dependency. There should be no cyclic dependency, right? And actually here there is no cyclic dependency, because you can see that why there is no cyclic dependency. Notice, you can see this SL2, there is no cyclic dependency. You can see this SL2, this depends on LL2. Okay, but this LL2 does not depend on SL2, so there is no cyclic dependency here. Yes or no? There is no cyclic dependency. There is no cyclic dependency. Okay, so that's it. Perfectly fine. So I can say this SDD, this is actually L attributed SDD. Okay, is this clear? Finally, your answer will be what? You can see this was our original question. And finally, our answer will be what? That which rules are S attributed, L attributed, that we have seen. And I can say this SDD, I can say this SDD is L attributed, but not S attributed. Okay, is this clear? This is actually L attributed. Okay, this is actually L attributed SDD, but this is not S attributed SDD. I hope you understood. Okay, so this we have already seen. Here you can see this is basically, this is the same previous question. So you can see this is L attributed SDD, but this is not S attributed SDD. Okay, I hope you understood this. Let's consider this SDD. Which rules are allowed in L attributed SDD? Which rules are allowed in L attributed definition, and which rules are allowed in S attributed definition? Okay, so let's see this quickly. Which rules are allowed in the S attributed definition? Which rules are allowed in L attributed definition? So let's see. Let's consider this rule for this production. In this rule, we are defining attribute V of B. B is on the LHS. So this is synthesized attribute. So this is allowed in both S attributed definition, also in L attributed definition. Okay. In this rule, we are defining attribute V of B. B is on the LHS. So this rule is again synthesized attribute. Yes or no? Because you are defining attribute of LHS. So this is synthesized attribute. So this rule is allowed in both S attributed definition, also L attributed definition. Let's see this rule. Here we are defining attribute V of L. L is on the LHS. So this is synthesized attribute. So I can say that this rule is again allowed in both S attributed definition, L attributed definition. Okay, let's see this rule. In this rule, we are defining attribute of capital L, that is on the LHS. So this is synthesized attribute, and you can see synthesized attribute defining is allowed. This rule is allowed in S attributed definition, also L attributed definition. Okay, let's see the next rule. In the next rule, we are defining attribute of L1. L1 is on the LHS. So this is synthesized attribute. So again, this is allowed in both S attributed, also L attributed definition. In this rule, we are defining attribute of L1. Okay, L1 is on the LHS. So we are defining attribute of LHS. So we are defining attribute of LHS means this is synthesized attribute. And you can see synthesized attribute is allowed in both S attributed definition, also L attributed definition. Okay. Let's see the next rule. In the next rule, we are defining attribute V of N. N is on the LHS. So this is synthesized attribute, and this rule is allowed in both S, L attributed definition. Let's see this rule. In this rule, we are defining attribute v of n. N is on the LHS. So this is also synthesized attribute. Okay. And you can see this semantic rule. This is allowed in both S attributed definition, also in L attributed definition. Okay. So finally, I can say that this SDD is both S attributed and L attributed. Okay. I hope you understood. Very simple. Now let's solve all the gate PYQs based on L attributed definition, S attributed definition. Okay. So let's solve gate 2020 question. The question is saying, consider the productions A going to PQ, A going to XY. These are two productions. Each of the five non-terminals A, P, Q, XY. You can see A, P, Q, XY. These are the non-terminals. They have two attributes. S is synthesized attribute, I is inherited attribute. Basically, all these five non-terminals, they have synthesized attribute S, inherited attribute I. This also has synthesized attribute S, inherited attribute I. Okay, very simple. Consider the following rules. Two rules are given to you. The question is asking which rules are L attributed rules. The question, basically the options are asking only for L attributed rules. Okay, means which rules are allowed in L attributed definition, which rules are allowed in L attributed SDD. Okay, so this is what the question is asking. So let's check one by one. Let's check the first rule. Okay, forget about the second rule right now. Let's check the first rule. In the first rule also we have multiple semantic rules. Okay, in the first rule you can see we have multiple semantic rules we have. Okay, so let's check these multiple semantic rules that we have. For example, look at this. Look at this. Let's check whether this rule is allowed in the L attributed definition or not. Okay, so basically let's check here. You can see we have pi equal to ai plus 2. Okay, so this is the semantic rule. First of all, you tell me one simple point. This pi equal to ai plus 2, this rule is associated with which production? There are two productions. So can you tell me this rule, this is associated with which production? Yes, this is associated with this production. Yes or no? Because you can see in this rule, we are using these non-terminals p comma a. Okay, in this production we don't have p. In this production we have p. So definitely this rule is associated with this production. Yes or no? So you can see that a pq, this is the production, and this is the semantic rule we have, that is pi equal to ai plus 2. P dot I means this is the inherited attribute of p. This is equal to a dot I plus 2. Okay, the question is already telling us that this p dot I, this is inherited attribute, a dot I, this is inherited attribute. The question is saying that I attribute is basically inherited attribute and S attribute is basically synthesized attribute. Okay, so you tell me this semantic rule, is this allowed in the L attributed SDD or not? You can notice here that in this semantic rule we are defining I attribute of p. P is on the RHS. We are defining attribute of RHS. So this is inherited attribute, and that is given in the question also, that p dot I, that is inherited attribute. Now this inherited attribute, this is depending on inherited attribute of the parent. Also it is depending on constant. So depending on constant, that is perfectly fine. And you can see this inherited attribute p dot I, this inherited attribute is depending on inherited attribute of parent. That is also perfectly fine. Yes or no? I told you inherited attribute can depend on inherited attribute of the parent, but inherited attribute cannot depend on synthesized attribute of parent. Here you can see p dot I, this inherited attribute is depending on inherited attribute of parent, that is allowed. Remember in the L attributed SDD, in the L attributed definition, any inherited attribute can depend on inherited attribute of parent, but not the synthesized attribute of parent. Also, any inherited attribute can depend on any attribute synthesized or inherited any attribute of left siblings. Okay, any inherited attribute can never depend on any attribute of its right siblings. Okay, and any inherited attribute can depend on its own attributes. Okay, but there should be no cyclic dependency between the attributes of itself. Okay, is this clear? So very simple, we have already seen, we have already done a lot of practice. The concept we have seen, the definition, the correct definition, the complete definition we have seen. Now you can easily see that this semantic rule is L attributed rule. Yes or no? I can say this semantic rule is L attributed rule because this inherited attribute is depending on inherited attribute of parent. Okay, you can see. I can say this is inherited attribute of parent. Inherited attribute of inherited attribute of A, and this A is basically the parent of P. Okay, this A is basically the parent of P. Okay, so you can see that this rule is allowed in L attributed SDD. Okay, so you can see this is the tick mark that this is basically L attributed rule. Okay, this is L attributed rule. Okay, let's see the next. Next, you can see we have this rule Qi equal to Pi plus Ai. Okay, so let's see this one also. Qi equal to Pi plus Ai. Okay, so here you can see Q dot I, the I attribute of Q, that is equal to P dot I plus A dot I. Okay, P dot I plus A dot I. Okay, so let's see. The question has already given to us that I attribute is inherited attribute, but actually you can find here also. You can see corresponding to this production, this is the semantic rule. In this semantic rule, we are defining attribute of Q, this attribute I of Q, and this Q is on the RHS, you can see. So we are defining attribute of RHS. So this is inherited attribute. So I can say that this I attribute, this is inherited attribute of Q. And this information is already given in the question. Okay, that this I is the inherited attribute of Q. So you can see this inherited attribute is depending on inherited attribute of left sibling, that is perfectly allowed in the L attributed definition. Also, you can see this inherited attribute is depending on inherited attribute of parent. Yes or no? A dot I, that is inherited attribute of A, that is given in the question. So you can see this inherited attribute is depending on inherited attribute of left sibling, also inherited attribute of parent. So this is perfectly fine. This is allowed in the L attributed rule. So I can say this is also L attributed rule. Okay, is this clear? Now let's see the next. You can see that is AS equal to PS plus QS. Okay, you can see AS equal to, with this production, this is the semantic rule that A dot S equal to P dot S plus Q dot S. Now notice one thing here. Already the question is saying that A dot S is a synthesized attribute of A. But actually you can find from this semantic rule also. You can notice corresponding to this production, we have this semantic rule. In this semantic rule, we are defining attribute of A. A is on the LHS. So this is a attribute of LHS. We are defining attribute of LHS. So this is synthesized attribute. So S is synthesized attribute of A. So this information either you can find from this semantic rule or you can find from the question. The question has already given to us that S is a synthesized attribute of A. And you can see here you are defining synthesized attribute of A. So synthesized attribute is allowed in the L attributed definition. So I can say that this is also perfectly fine. This is also L attributed rule. So I can say that all the three rules in the rule number one, we have total three rules. All these three rules are basically L attributed rule. Okay, so I can say that this also, okay, I can say that, okay, I can say this also is L attributed rule. Next, this also is L attributed rule. Next, this also is L attributed rule. Okay, so I can say that rule number one, yes, this is L attributed rule. Okay, yes or no? So I can say this is L attributed rule. Means the rule number one, this is allowed in the L attributed SDD. This is allowed in the L attributed definition. Okay. So very simple. Which option is gone? You can see only rule 2 is L attributed. No. Neither rule 1, rule 2 is L attributed. No. Okay. Still, we have to check the rule number 2 also. Okay. So let's check the rule number 2 now. Now we need to check the rule number 2. Forget about rule number 1 now. Okay. So now let's check this rule number 2. In the rule number 2, you can see we have this rule and this rule. Okay. And you can see these rules are basically associated with this production, because you can see in these semantic rules we are using x dot I, y dot s, y dot I, x dot s. And you can see that in this production we have x comma y. In this production we don't have x comma y. Okay. So I can say that with this production a going to xy, with this production we have these rules associated. You can see xi equal to ai plus ys. Okay. X dot I is equal to y dot xi equal to ai plus ys. Okay. Xi is equal to ai plus ys. Ai plus ys. Okay. Now remember, the question has already given to us that this I attribute, this is a inherited attribute of X. But actually you can find from here also. You can notice in this semantic rule, we are defining I attribute of X. X is on the RHS. So we are defining attribute of RHS. So this is inherited attribute. So I can say that from this rule, you can say that this I is inherited attribute of X. Okay, but this information is already given in the question that I attribute is inherited attribute of X. Okay, now you can see this inherited attribute is depending on inherited attribute of parent. That is perfectly fine. Okay, this inherited attribute x dot I, this is depending on inherited attribute of parent. That is perfectly fine. In the L attributed definition, the inherited attribute can depend on inherited attribute of parent. Okay, but inherited attribute cannot depend on synthesized attribute of parent. Okay, inherited attribute can depend on any attribute of left siblings. It cannot depend on any attribute of right siblings, like that. Okay, so you can see that here this inherited attribute x dot I, this is depending on inherited attribute of parent. That is perfectly fine. But you can notice that this inherited attribute x dot I, this is depending on attribute of right sibling. This y is the right sibling. So you can see that this is not allowed. Yes or no? Are you getting my point? So I can say overall, I can say this rule, this is a not L attributed rule. This rule is not L attributed rule. This rule is not allowed in the L attributed definition. Okay, I hope this point is clear. So you can see that this rule is not L attributed rule. So automatically I can say this rule 2 is also not L attributed rule. Okay. Already we have seen that rule 1 is L attributed rule. So what will be the answer? The answer will be only rule 1 is L attributed rule. The answer will be option B. Okay. But still, let's check this also. Is this violation or not? Okay. So let's check this also. Yi equal to xs plus ai. Okay. So let's check this also. Yi is equal to xs, x dot s plus a dot I. Okay, let's check this. Here you can notice the question has already given that I attribute is inherited attribute of y, but actually you can deduce this from this semantic rule also. You can notice in this semantic rule for this production, in this semantic rule we are defining this attribute I of y. Y is on the RHS. We are defining attribute of RHS. So this is inherited attribute. So I can say I is inherited attribute of y. So you can see, you can deduce from this semantic rule that this I attribute, this is a inherited attribute of y. Okay, now you notice this inherited attribute, it depends on attribute of left sibling synthesized attribute of left sibling, that is perfectly fine. Okay, inherited attribute can depend on any attribute of left siblings. Synthesized or inherited, any attribute of left siblings you can depend on. Okay, so this is perfectly fine. Next, you can see this inherited attribute y dot I. This is depending on inherited attribute of parent, that is also allowed. Okay, any inherited attribute can depend on inherited attribute of the parent. But remember, any inherited attribute cannot depend on synthesized attribute of the parent. Okay, so here you can see this inherited attribute y dot I. This is depending on inherited attribute of the parent. This is perfectly fine. So I can say actually this is L attributed rule. Okay, this is L attributed rule. I hope you understood. So remember, yes, this is L attributed rule. Okay, so you can see because in this rule 2, this is not L attributed rule. So overall, this rule 2 is not L attributed rule. Okay, so the answer will be option B, which is true. Only rule 1 is L attributed rule. I hope you understood this. Okay, now let me ask you one variation in this question. In this question, let me ask you a variation in this GATE 2020 question. You can see. Let me ask you one variation. If I give you a rule 3, okay, let's assume I give you a rule 3. I am making the small change in this rule 1. See, in this rule 1, you can notice, consider this. Consider this. I am making a small change. Let's assume that I have P dot I is equal to A dot S plus 2. Okay, P dot I equal to A dot S plus 2. Now you tell me, this is rule 3. Now you tell me, is this L attributed rule or not? This rule 3, is this L attributed rule or not? I am asking, my question is rule 3 L attributed? Means the rule 3, is it allowed in the L attributed definition or not? The answer is no. The answer is no, because notice here, this P dot I, this is inherited attribute. Okay, you already know the production. The production is A going to PQ. A going to PQ, this is the production, and with this production, this semantic rule is associated. Okay, now notice that this P dot I, this is the inherited attribute. This inherited attribute is depending on synthesized attribute of the parent. That is not allowed in L attributed definition. So you can see that this is the problem. Okay, because this is the synthesized attribute of parent. This is the synthesized attribute of parent. Okay, so remember this rule number 3, remember this will not be L attributed rule. Okay, yes or no? Is this clear? So I can say not L attributed rule. I hope you understood this. Okay, let's solve GATE 2025 question. Given the following syntax directed translation rules, rule 1, rule 2, rule 3, these are given to us. You can see corresponding to this production we have these semantic rules. For this production we have these semantic rules. For this production we have these semantic rules. Okay, the question is asking which one is correct option among the following. The question is asking rule 1 is S attributed and L attributed, rule 2 is S attributed, not L attributed. Basically the question is asking these rule 1 to rule 1, rule 2, rule 3, these are S attributed, these are L attributed. This is what we need to check. Okay, for each rule we need to check, is it S attributed rule, is it L attributed rule. Okay, so this is the question. Now let's solve it. So one by one we will check all the rules. So let me check the rule number 1 first. Okay, forget about rule 2 and rule 3, forget about them. Let's check the rule number 1. Okay, in the rule number 1 you can see we have actually multiple rules. Okay, you can see there is rule this. Okay, there is another rule here, and you can see there is another rule here. Actually there are 3 rules. Okay, so let's check. Notice one thing, this is the production and these are the associated semantic rules. Okay, so you can check this one. Okay, let's check this one. Are going to, let me write, this is the production are going to AB. Okay, R is the LHS, A comma B are on the RHS, and this is the rule associated B dot I equal to R dot I minus 1. Okay, now notice one thing, in this semantic rule which is associated with this production, in this semantic rule we are defining attribute of B is on the RHS, yes or no? This attribute I of B we are defining, and B is on the RHS, we are defining attribute of RHS, so this is inherited attribute of B, yes or no? This is one thing, that this I is inherited attribute of B, this I is inherited attribute of B. And notice one thing, inherited attribute is not allowed in as attributed definition, yes or no? So one thing you can immediately you can say, because here this inherited attribute of B you are computing, okay, so that is the reason I can say this is not as attributed rule. Okay, this is not as attributed rule, definitely this is not as attributed rule. Okay, because you are defining inherited attribute in this rule. Okay, so overall I can say this rule number 1, this is also not as attributed rule. Okay, for this rule number 1 also we can say. What about the L attributed rule? So here you can see this inherited attribute we are defining, and this inherited attribute is defined in terms of attribute of parent. This is attribute of parent, this is attribute of parent, this is attribute of parent. Notice one thing, we don't know this is synthesized attribute of parent or this is inherited attribute of parent. Please understand, I does not mean that this is a inherited attribute. Okay, the question does not mention that I means inherited attribute. Okay, so what some students do, they by default assume that I will be inherited attribute, S will be synthesized attribute, like that. Please don't do that. Okay, here this I is basically attribute, they did not mention that this is a synthesized attribute or inherited attribute. Also remember, this I attribute, maybe this can be synthesized attribute for one terminal, for one non-terminal. For some non-terminal, this I can be synthesized. For some non-terminal, this can be inherited. Okay, so don't assume, don't make any assumption that I is inherited. For some non-terminal, I can be inherited. For some non-terminal, I can be synthesized. Okay, so here notice one thing, this rule, in this rule, this inherited attribute depends on attribute of parent. I told you in the L attributed definition, inherited attribute can depend on inherited attribute of the parent, but inherited attribute can never depend on synthesized attribute of parent. So here we need to check this R dot I, is this inherited attribute or is this synthesized attribute of parent. Okay, so remember here we need to check if R dot I is synthesized or inherited, yes or no? We need to check if R dot I is synthesized or inherited. Okay, so let's check how you will check. This information is not given in the question that R dot I is synthesized or inherited. This information is not given in the question. Then how will you check? You can check here. Look at this. In this semantic rule, we are defining R dot I. R is on the LHS. Yes or no? Please understand here something interesting. You can see, look at this semantic rule. In this semantic rule, we are defining R dot I. R is on the LHS. We are defining attribute of LHS. We are defining attribute of LHS means this is synthesized attribute, yes or no? So from here you can see that R dot I is synthesized. R dot I is synthesized. Okay, is this clear? Very simple. So notice one thing, that we have found that this R dot I is synthesized. Is this clear? This R dot I is synthesized. R dot I is synthesized. Okay, and now notice this inherited attribute is depending on synthesized attribute of parent. Is that allowed? In the L attributed definition, is it allowed that inherited attribute is depending on synthesized attribute of parent? No, that is not allowed. Yes or no? This is synthesized attribute of parent. Okay, so this rule, remember, this rule, this is not L attributed rule. This rule is not L attributed rule. Is this clear? So finally, actually, you can stop here and you can say that this rule number one, this is not S attributed rule. This is not L attributed rule. Okay, you don't even have to check the remaining. Of course, we will check the remaining for the sake of complete analysis. But I am just saying that from this first rule itself, you can say that this rule number one, this is neither S comma L. Okay, is this clear? You can say neither S attributed rule nor L attributed rule. Okay, is this clear? Very simple. But let's check the remaining also just for sake of complete analysis. So let's check in this rule number one. In this rule number one itself, already you can see this we have already checked. Okay, this we have already checked. This is not S attributed rule. This is not L attributed rule. Okay, let me assume that first tick mark, first tick for S attributed rule. Okay, means here I'm putting cross, means this rule is not this rule is not S attributed rule. So remember, first tick mark that I'm putting, the first tick mark that I'm putting, that is for S attributed rule, and second tick is for L attributed. Okay, now let's see the next one. Okay, what about this one? Here you can see that A dot I, notice, are going to AB. This is the production, and this is the semantic rule associated. A dot I is equal to B dot I. A dot I is equal to B dot I. Okay, now notice that this A dot I, this is inherited attribute. Okay, why this is inherited attribute? How do I know that A dot I is inherited attribute? Because you can see this semantic rule is associated with this production, and in this semantic rule we are defining A dot I. A is on the RHS. We are defining attribute of RHS. Because we are defining attribute of RHS, so this is inherited attribute. So remember, A dot I, this is inherited attribute. This is inherited attribute. Because this is inherited attribute, here you are defining inherited attribute, so definitely this is not S attributed rule. Okay, this is not S attributed rule. What about L attributed rule? You can see this inherited attribute depends on attribute of B. B is the right sibling. Yes or no? For A, this B is the right sibling. This is the right sibling of A. This is the right sibling of A. So you can see that this inherited attribute of A depends on attribute of right sibling. This is not allowed in L attributed definition. So you can see this rule is also not allowed in L attributed definition. Okay, very simple. I hope you understood. Now let's see the last, this one. R dot I is equal to A dot I plus 1. Here you can notice this R dot I. In this rule, we are defining R dot I. R is on the LHS. So we are defining attribute of LHS. So this is synthesized attribute. Synthesized attribute is allowed in S attributed definition, L attributed definition. So I can say that this is actually perfectly fine. Okay, this is perfectly fine, because here you can see we are defining attribute of LHS. So actually this R dot I, this is synthesized. You are defining attribute of LHS, means this is synthesized attribute. Okay. When we define attribute of LHS, that is synthesized attribute. When we define attribute of RHS, that is inherited attribute. Okay. So R dot I, that is basically synthesized attribute. So this particular rule is allowed in S attributed definition, also in L attributed definition. But you can see these two rules are not allowed in S attributed definition. Also, these two rules are not allowed in L attributed definition. So overall, this rule 1, this is neither This is neither S nor L attributed rule. Okay, is this clear? Now, can we eliminate the options? Like, do we need to check rule 2, rule 3, or can we eliminate the options? You can see rule 1 is S attributed, that is wrong. Rule 1 is S attributed, that is wrong. But still, option B comma C we need to check, because option B comma C are saying that rule 1 is neither S attributed nor L attributed. Okay, so we need to check option B comma C. So let's check this rule number 2, then let's check rule number 3. For sake of complete analysis, we will check all these rules. Okay, so let's check the rule number 2 now. Okay, forget about rule number 1, forget about rule number 3, just focus on rule number 2. Okay, so in this rule number 2, basically we have two rules here. One is pi equal to ci plus di, another is di equal to ci plus 2. Okay, these are the two rules. So let's check both of them. You can see we have p going to cd, this is the production, and with this production the associated semantic rule, that is pi equal to ci plus di. Okay, remember we don't know for a non-terminal I is inherited or synthesized. For some non-terminal I can be synthesized, for some non-terminal I can be inherited. The question does not mention that I means inherited. Okay, that the question does not mention. So we have to check. Okay, so let's check. Notice one thing in this semantic rule associated with this production. In this semantic rule, we are defining p dot I attribute of p. And you can see this p is on the LHS. So we are defining attribute of LHS. We are defining attribute of LHS means this is synthesized attribute. And remember, synthesized attribute is allowed in S attributed definition, also L attributed definition. So actually, this is perfectly allowed. Okay, so I can say this is both S attributed also this is L attributed. Now let's check the next one. You can see P going to CD, this is the production. And the associated semantic rule, that is D dot I is equal to C dot I plus 2. Okay. Here you notice we are defining attribute I of D. Attribute I of D, we are defining D is on the RHS. So we are defining attribute of RHS. So this is inherited attribute. Remember this D dot I, this is inherited attribute of D. Okay, so I can say D dot I is inherited attribute. Okay, here actually I can write that this p dot I was synthesized attribute. So I attribute is synthesized attribute for p, I attribute is inherited attribute for D. Okay, now let's see. So you can see that in this semantic rule, we are defining I attribute of D, D is on the RHS, we are defining attribute of RHS. So this is inherited attribute. Now you can see this inherited attribute is depending on constant, that is perfectly fine. Okay, depending on constant is fine. Also you can see depending on constant is fine. Also you can see that this inherited attribute depends on attribute of left sibling, so that is also perfectly fine. Remember, inherited attribute can depend on any attribute of left sibling, synthesized or inherited. You can depend on any attribute of left sibling. Okay, so here I can say that this is L attributed definition, this is L attributed rule. Okay, this rule is basically L attributed rule. But notice one thing, that this is not S attributed rule. Why this is not S attributed rule? What is the reason this is not S attributed rule? Because in S attributed SDD, all the attributes must be synthesized. Here you can see actually we are defining inherited attribute. This D dot I, this is inherited attribute. We are defining inherited attribute in this rule. So this rule is not allowed in S attributed definition. This rule is not allowed in S attributed SDD. This rule is not S attributed rule. Okay, is this clear? So overall I can say this rule 2, overall I can say that this rule 2, this is not S attributed, this is not S attributed rule, but it is L attributed rule. Okay, because you can see In this rule 2, there are two rules, and both the rules are basically L attributed. Both the rules are L attributed. So overall, this rule 2 is L attributed rule. And you can see in this rule 2, there are two rules, and one of them is not S attributed rule. So I can say this rule 2 is not S attributed rule. Okay. Simple, right? So which option I can eliminate? Already option A gone. Option D was already gone. Now rule 2 is S attributed and L attributed. This is also gone. So option B is also gone. And you can say answer will be automatically option C. Okay. So answer will be option C. Now, for sake of complete analysis, let's check this rule 3 also. Okay. So let's check this rule 3. Forget about rule 1, rule 2. Now let's check the rule 3. In the rule 3, we only have one rule. You can see Qi equal to EI plus Fi. Okay, so this is the production. Q going to EF. Q is on the LHS, EF are on the RHS. So you can see Q dot I is equal to E dot I plus F dot I. Okay, now let's see here. First of all, we don't know this I attribute, this is inherited or synthesized for Q. Okay, but we can check it, we can find it from this semantic rule. You can see in this semantic rule, we are defining I attribute of Q. Q is on the LHS. We are defining attribute of LHS. So this is synthesized attribute. Yes or no? So very easy that this I attribute is synthesized attribute of Q. I attribute is synthesized attribute for Q. I attribute is synthesized attribute for Q. Okay, is this clear? So you can see that in this rule, we are defining synthesized attribute. Yes or no? And synthesized attribute is allowed in S attributed definition, also in L attributed definition. Okay, yes or no? So I can say that this is both L attributed, also S attributed definition. Or I can say this is basically, this rule is allowed in S attributed, also L attributed definition. So this rule is basically, this rule is both S attributed rule and L attributed rule. Okay, so that's it. This is your final answer. Answer will be option C. Rule 2 is not S attributed, but it is L attributed, and rule 3 is S attributed and L attributed. So the answer will be option C. I hope you understood. Very simple. Let's solve this question taken from Ullman book, Ullman exercise question. Suppose that we have a production A going to BCD. Each of the four non-terminals ABCD have two attributes. S is synthesized attribute, I is inherited attribute. In this question, it is already given that S attribute is synthesized, L attribute is, I attribute is inherited. Okay, S is synthesized attribute, I is inherited attribute. For each of the set of rules below, tell whether the rules are consistent with S attributed definition, the rules are consistent with L attributed definition. Okay, so let's check all these rules. Let's check the first rule. The first rule is A dot S equal to B dot I plus C dot S. Okay, so let's forget about the remaining. Let's just focus on this option A. Okay, so here you can see, remember the production is what? The production is A going to BCD. This is our production. And with this production, we have associated semantic rule, that is A dot S is equal to B dot I plus C dot S. Notice one thing, the question is already saying that A dot S is a synthesized attribute. So in this rule, we are defining synthesized attribute, and that is consistent with S attributed definition also. That is consistent with L attributed definition. Yes or no? You are defining synthesized attribute. So defining synthesized attribute, this rule is allowed in both S attributed definition, also in L attributed definition. Okay, so I can say that yes, this is allowed in both. So this rule basically, this is, I can say this rule is basically both S attributed rule, also L attributed rule. Okay, this is S attributed rule, also L attributed rule. I hope you understood. One more thing you notice. Actually, the question has given that S is synthesized attribute. If the question does not give, let's assume, if the question does not give that S is synthesized attribute, then can we figure it out from this rule? From this semantic rule, can we figure it out? Yes, we can figure it out because notice in this semantic rule, we are defining S attribute of A. A is on the LHS. We are defining attribute of LHS. In this semantic rule, we are defining attribute of LHS. So this is a synthesized attribute of A. Okay, yes or no? So if this information is not given in the question that S is synthesized attribute, then also we can figure it out that S is a synthesized attribute for A. Okay, yes or no? A dot S is synthesized. This we can figure out also. I hope you understood. So very simple that this option A, this rule is consistent with S attributed definition as well as L attributed definition. Okay, so I can say that this is both. I can say this is both S comma L. Okay, I can select this. Now let's see the next one. In the next one, let's focus on B. Okay, so let's see this one. So what we have, okay, forget about A, forget, only focus on B. So here you can see this is the production, A going to BCD, this is the production, and here you have two rules. Okay, there is one rule like this and there is another rule like this. Okay, so let's see. So you can notice one thing, here you are defining synthesized attribute, yes or no? Because notice in this rule we are defining A dot S. A dot S is synthesized attribute. So in this rule, we are defining synthesized attribute. So this is allowed in S attributed definition as well as L attributed definition. Yes or no? Okay, so I can say that this is basically, this is both. This is allowed in both S comma L attributed rule. Okay, is this clear? So this is perfectly fine. Also, you can notice in the question, if it is not given that S is synthesized attribute, if this is not given, then also we can figure it out. Then also we can figure out, because notice for this production we have this semantic rule. In this semantic rule, we are defining attribute of A, attribute S of A, and this A is on the LHS. So in this semantic rule, we are defining attribute of LHS. So it is synthesized attribute. So S is synthesized attribute of A. Okay, very simple. Now let's see this one. Di equal to Ai plus Bs. Okay, so it's like for this, with this production, we have this semantic rule. Di is equal to Ai plus B dot S. Now, notice one thing. The question has already given to us that I is inherited attribute. But if that is not given, then also we can figure it out, because in this semantic rule, we are defining attribute I of D, and D is on the RHS. So in this semantic rule, we are defining attribute of RHS. So this is an inherited attribute. So I can say I is inherited attribute of D. Okay, I can say D dot I is inherited. You can figure it out also. If it is not given in the question, then also you can figure out. Now, you can see this inherited attribute depends on inherited attribute of parent. Yes, that is allowed. Yes or no? Depending on inherited attribute of parent is allowed. And you can see this inherited attribute depends on attribute of left sibling. That is also allowed. Remember, in L attributed definition, in L attributed SDD, any inherited attribute can depend on any attribute of left sibling, inherited or synthesized. So you can depend, any inherited attribute can depend on any attribute of left siblings. But remember, any inherited attribute depends on, can depend on, it can depend on inherited attribute of parent, but any inherited attribute can never depend on synthesized attribute of parent. Okay, I am talking about L attributed definition. So here you can see that this inherited attribute depends on inherited attribute of parent, that is perfectly allowed, and it depends on synthesized attribute of left sibling, that is also allowed. Okay, so I can say that this is a L attributed rule. This is L attributed rule. Okay, but notice this is not S attributed rule. Why? Because in S attributed SDD, all the semantic rules must define synthesized attribute. Yes or no? In the as attributed SDD, in the as attributed definition, all the semantic rules must define only synthesized attribute. But here you can see this d dot I, that is inherited attribute, you are defining in this semantic rule, you are defining inherited attribute. So this is not consistent with as attributed definition, or I can say this is not as attributed rule. This is not as attributed rule. I hope it is clear. Okay. So overall for this B, what I can say? Overall for this B, I can say, for this B, I can say it is not S but L. Not S but L. Option A, that was both S comma L. Okay. Now let's see the option C. Okay. Forget about option D. Let's check for option C. In option C, you can see we are defining a dot S, which is synthesized attribute. So this is perfectly fine. Yes or no? You can see we are defining synthesized attribute. The question is already saying that S is synthesized attribute of A. Okay, so you can see you are defining synthesized attribute. So this is both S attributed rule, also L attributed rule. Okay, both. Is this clear? Means this rule is consistent with S attributed definition. Also, this rule is allowed in L attributed definition. Okay, remember in the question, if it is not given that S is synthesized, if that is not given, then also we can figure it out, because you know the production is A going to BCD, and with this production, if I write this semantic rule, then you can see here we are defining attribute of A is on the LHS. So in this semantic rule, we are defining attribute of LHS. So this is a synthesized attribute. So S is synthesized attribute of A, and defining synthesized attribute is allowed in S attributed definition, also in L attributed definition. Okay. Now let's see option D. The last option, let's check. In the last option, we have this rule, then we have this rule, then we have this rule, and then we have this rule. Basically 4 rules in this option D. Okay, so let's see quickly. You can notice we have this production A going to BCD. A is on the LHS, BCD are on the RHS. Now here you can notice that we are defining synthesized attribute, or you can see in this rule we are defining attribute of A is on the LHS. So in this rule we are defining attribute of LHS. So this is synthesized attribute. So I can say that this is allowed in both S comma L. Okay, is this clear? Defining synthesized attribute is allowed in both S attributed definition, also L attributed definition. Okay, very simple. What about the next? What about this next semantic rule? Here you can see B dot I. I is inherited attribute of B. Actually, you can check that in this semantic rule, we are defining attribute of B. B is on the RHS. So in this semantic rule, we are defining attribute of RHS. So this is inherited attribute. So here B dot I, that is inherited attribute. And you can see that this inherited attribute is depending on synthesized attribute of parent. Depending on synthesized attribute of parent, that is not allowed in the L attributed definition. Also notice one thing, that this inherited attribute is depending on attribute of right sibling, that is also not allowed. Yes or no? So actually here also problem, here also problem, violation. Okay, yes or no? This is also, both are basically violations. Is this point clear? So I can say that this rule is not allowed in the S attributed definition. Also this is not allowed in L attributed definition. Okay, because in this rule you are defining inherited attribute, so this is not allowed in S attributed definition. And because this inherited attribute depends on synthesized attribute of parent, so this rule is not allowed in L attributed definition. Also this inherited attribute depends on attribute of right sibling, so that is another reason that this rule is not allowed in L attributed definition. Okay, is this clear? Now let's see the next. C dot I equal to B dot S. Remember C dot I, that is inherited attribute, or you can say that this rule is associated with this production, And in this rule, we are defining attribute of C, and C is on the RHS. So in this rule, we are defining attribute of RHS. So this is inherited attribute. And because you are defining inherited attribute here, so definitely this rule is not allowed in S attributed definition. What about L attributed definition? You can see this inherited attribute depends on attribute of left sibling. That is allowed. Yes or no? So yes, this rule is allowed in L attributed definition. What about the next rule? In the next rule, d dot I, that is inherited attribute, you are defining inherited attribute here. So this rule is not allowed in S attributed definition. What about L attributed definition? You can see this inherited attribute d dot I, this depends on attributes of left sibling. Yes, that is allowed. Okay, so you can see, notice in this semantic rule, we are defining attribute I of D. D is on the RHS. So in this semantic rule, we are defining attribute of RHS. So this is a inherited attribute, D dot I. This is inherited attribute. Also, this is given in the question that I is inherited attribute for all the non-terminals. So D dot I, that is inherited attribute. Okay. Now you can see this inherited attribute is depending on attribute of left siblings, B comma C. These are the left siblings. So remember, in the L attribute definition, any inherited attribute can depend on any attribute of left siblings, synthesized or inherited. Okay, any inherited attribute can depend on any attribute of left siblings. So here you can see this d dot I, this is depending on attributes of left siblings. So this is allowed in L attributed definition. Okay, so you can see this option D. Notice in this option D, this particular rule is not consistent with L attributed definition. Also, it is not consistent with S attributed definition. So I can say this option D, for this option D, I can say this is neither S, comma, this is neither S nor L attributed rule. Attributed rule. Okay. I hope you understood. So finally, we have got the answer. This is both S comma L. This was L but not S. This was both S comma L. And this one, this is neither, not S, not L. Okay. So this is your Ullman exercise question, Ullman book exercise question. I hope you understood. Okay. So that's enough for this lecture. In this lecture, we have seen S attributed SDD, L attributed SDD. Also, we have seen synthesized attributes, inherited attributes. Okay, all these concepts we have seen, and we have done all the gate PYQs based on S attributed SDD, L attributed SDD. Okay, so based on these concepts, all the gate PYQs also we have done. Now, in the next lecture, we will study evaluation order of SDD. Okay, so almost this is the last topic, evaluation order of SDD. How we can evaluate SDD, that we need to study in the next lecture. This is the last topic. Okay, there are some subtopics in this topic. I can say when we study the evaluation order of SDD, then some small subtopics we need to study. For example, what is circular SDD? Okay, so what is dependency graph, like that. Okay, so that we will discuss, that we will study in the next lecture. Okay. Okay, thank you everyone. Please share your feedback. I hope you understood each and every concept in this lecture. I hope you understood the complete analysis of each and every question that we have seen. Okay, thank you. Thank you everyone.